Please confirm that you can hear me. Kevin, I see you online. Can you just confirm that you can hear and see this?
Yes, we can hear Prof and we can see.
So if you would just indulge us, and maybe we can start at 9:15. Apologize for the delay, but I'm not sure if there are traffic issues or what's happening, but we're still expecting 1 or 2 students for the first session that aren't here yet. So if we could give us another 5 minutes and we'll start at 9:15. My apologies.
Test.
That's what everybody is seeing at the moment. He's seeing your screen.
Is that what they all see there?
Yeah. And
So how do we do that?
So
Duplicate. Duplicate. Okay. Maybe I should be on extended then.
no, if you go and extend it, then it comes to that mode.
Let's see what happens.
See, still got your screen.
So how do we solve it?
See, this is what we want.
Yeah, but then how do we make this master?
It has to be on this. That's when it's gonna happen. But you only have your notes.
Yeah, pause it.
So if I want to change clearing,
Yeah.
We go, yeah. We're sharing.
We never start sharing as yet. So just click on the green. Okay, and then go to start sharing. Oh, yeah, that one. Click on the PowerPoint now. Should come up. Yeah, there.
You know, this is coming. No,
So,
that's fine.
yeah, but
Are you seeing that?
yeah, see what that's what we're seeing also your screen.
You gotta go to duplicate.
Let's see. Then go to PowerPoint. So yeah, let's go to PowerPoint now.
So then you still see
Yeah.
that. What did you do it like that, Ruben?
You can take something.
I wouldn't see the
Single. Yeah, it's single, yeah. You have to make it smaller.
I feel like
Let's make it small. Yeah, yeah. Or you can make it one and then you can follow.
how do I do?
Click on this. No, put it in next one.
That's right.
Yeah.
That takes it away.
Yeah, the thing.
Please make sure you're on mute, otherwise you're going to get feedback. Good morning, everybody, online delegates. Can anybody put your camera on, please? Just to check that we can see you. Or confirm that you can hear me. Good morning,
We
Kurt.
can hear you, but your slide is not in presentation mode.
Not in presentation mode.
Put it
Thanks,
in
Peter.
presentation mode in PowerPoint, bottom of PowerPoint.
Oh, now it's good to start sharing.
Do you want to stop sharing? Okay. Why have we got all these three of them?
Yeah.
Am I sharing the wrong one?
Which one is it?
I don't know.
Try to.
Yeah, that's perfect.
Thanks, Peter.
Can see
So
it.
it's, you would just chose the wrong screen there. We've got so many screens running around here. I can't count them all.
Okay. Can you turn this video on?
Peter, can you turn your camera on just so they can check that the videos are working on this side? There, Peter's just put his camera on.
Chair, if I can see you.
Thanks very much. Thanks, Glenn. Did you see
Okay,
Glenn as well? Glenn just put his camera on as well.
Yeah, I did see Glenn as well.
Great.
Just we're not seeing Glenn at the moment. I don't know if it's how do we work that? Okay, there we can see Glenn. So if you are talking, you will come up on the screen here as well. That's wonderful. Thank you.
Thanks, guys.
Can you see that, Joel? Can you see that, Joel? Yeah. He's saying that as well. Clickers now, not. Clickers now, not. Was working. Can be real pain without it. But this is on presentation right now. Okay. Move it up. Sorry. Right. Good morning, ladies and gentlemen. Is the mic on? Can you hear me okay? That okay? Good. I apologize for the delay in start. I guess these hybrid events are going to become more popular and commonplace as we move into the future. And hopefully we'll get all the technology up and running beforehand properly. So I'd really like to welcome you all. I'd also like to welcome those of you online to the second symposium of the Umgeni Water Chair of Water Resources Research and Innovation. Sorry. Right. Sorry, apologies for that. So my name is Jeff Smithers. I'm currently the Umgeni Water Chair of Water Resources Research and Innovation at the University of KwaZulu-Natal. I'm also the director for the Centre for Water Resources Research at the University of Natal. As I said, I'd really like to extend a warm welcome to you. I think we are still expecting some more people who are still on their way. And we have got quite a few online. I don't know offhand, but I did see there are quite a few people online, so I hope you can all hear. I think we've got some honored guests with us as well. We've got the chairperson of the board of Umgeni Water, and Ms. Dr. Gabsi Matenzwa. So very welcome to you. We've also got the acting CEO of Umgeni Water, Dr. Manana, with us here in the venue. So again, a very warm welcome to you. And I think with that, I'm not going to go through all the dignitaries, all protocols observed. So thank you very much for that. I have got a list of apologies here. I don't know if anybody else wants to note any apologies. So these are apologies that were submitted to the invitations that were sent out. If anybody wants to note any other apologies. If not, we're going to move on to the next slide. Right, just to give you some background, the Memorandum of Understanding between University of KwaZulu-Natal and Umgeni Water was established in July 2020. It has recently been renewed in April 2021, and again for a 10-year period. And really the aim of the MOU is to establish mutually beneficial projects in teaching, research, and technical services, and also to establish an endowed chair at UKZN. So Umgeni Water have supported the professorial chair since July 2020. That first 10-year period has recently expired and just been renewed, as I said, in April 2021 for another 10-year period. And the name has been changed from the Umgeni Water to the Umgeni Water Chair of Water Resources Research and Innovation. So Umgeni Water provides funds to support the chair, as well as postdoc and postgraduate students through the chair. And again, just to give my view of what the MOU is trying to achieve, as well as the memorandum of understanding between Umgeni Water and UKZN, we're really focusing on national capacity development, both at undergraduate teaching level as well as research through postgraduate students and student supervision. We obviously want to conduct research in water resources related matters and related fields. And the idea is also to promote closer collaboration between UKZN and Umgeni Water. So given the proximity, it makes sense to promote that closer collaboration and also encourage research activities at UKZN to focus on issues that are required by Umgeni Water. So really trying to facilitate that collaboration between the two institutions. And also trying to focus the research activities at UKZN on the research and development master plan, which Umgeni Water has. So really trying to prioritize those research projects. So if we look at the support for research activities, Umgeni Water currently funds the chair funding, also funds 2 postdocs, which has recently expired, and we're busy renegotiating those. Also funding a whole bunch of postgrad students, which I'll allude to in a minute. And then there have been historically specific research contracts with particular groupings within UKZN directly with Umgeni Water. At the same time, the University of KwaZulu-Natal Research Office has also been supporting a postdoc administered through the Umgeni Water Chair. So this is to complement the 2 postdoc students that are funded by Umgeni Water. And again, so that the University of KwaZulu-Natal has recommitted to funding that chair for another 2-year period. So we have really been very blessed to have significant funding support from Umgeni Water, not only for the Umgeni Water Chair, but also for student funding. So as I said, we're supporting 2 postdoc students directly from funding from Umgeni Water. And just to give you some indication, in 2021, we were supporting 19 postgraduate students. In 2022, we're supporting 26 postgraduate students. And we'll be hearing from a lot of those during the short presentations during the day. In terms of funding, so for example, through the chair, we've supported more than 1.3 million rands worth of bursaries in 2021 and more than 2.7 million in 2022. And that's in addition, there have been some various specific research contracts directly between groupings within UKZN and Umgeni Water. So the funding that we've received from Umgeni Water is significant, and we deeply appreciate the funding that we have received and support that we have received. What we are wanting to do with this symposium is really give feedback to industry, basically Umgeni Water, on some of the research findings and activities and progress that is being made in the research projects. We want to allow opportunity for questioning. I really want to encourage that between industry leaders and the academic supervisors, as well as the students. So we're really trying to promote communication and collaboration between the 2 institutions. We want to create awareness at UKZN of the research that is being funded by Umgeni Water at the university. And I think we also very often tend to work in silos. We want to try and break down those silos. We want to look at some multidisciplinary collaboration. I think quite often when you're in a venue like this, and I'm very pleased that we are face-to-face, or some of us are face-to-face, it really facilitates that collaboration and realizing what other people are doing and promoting collaboration. I'd then like to just hand over to Umgeni Water to make a welcome. And Dr. Wilson John is online, but I think Msebo Mkizi will be doing the welcome from Umgeni Water. Msebo. Why don't you ask him? Please.
Good morning, everyone. Greeting to all. I would like to give the opportunity to the chairperson of Umgeni Water. Okay, thanks, Dr. Manana. Okay, good morning. Greeting to Umgeni Water Board Chairperson, Kapsi Matendra, Executive, Chief Executive, Dr. Manana, all our executive management, industry leaders, and fellow colleagues, University of KwaZulu-Natal executives, and academic leaders, Professor Jeff Smitha, postdoctoral fellows, UKZN, postgraduates, students, researchers, and all other attendees. It is a great pleasure that I will welcome to you to the 2nd annual research symposium of Umgeni Water Chair of Water Resource Research and Innovation. Umgeni Water sees itself as a learning organization whose long-term vision to take upon global leadership position in the sector. We are on a firm belief that investing in research, development, and innovation would be a key element in achieving our targets and objectives. Our research agenda covers a diverse field of study as set out in Umgeni Water R&D Master Plan. Partnerships with academia is an integral on execution strategy. Through Umgeni Chair for Water Research and Innovation Initiative, our main aim or objectives are: number one, the human capital development to develop a cohort of water scientists, engineers, and researchers to create a growing knowledge economy. Number two, to facilitate and promote cross-disciplinary research. Third one, to collaborate internationally and internationally. The fourth one, to translate scholarly work into a high-impact innovation to a current future and economic growth and sustainability. The last one is to undertake the applied research in support of evidence-based policy development. We are indeed pleased to have UKZN as a key partner in driving some of our research efforts. We trust that this symposium and others to follow in future will foster the improved and new work relationship as we collaborate finally solution to sector challenges. We wish all the researchers and presenters well ahead of today's proceeding. I will hand over to Jeff. Thanks.
Thank you very much for those words from Umgeni Water. I think I'd also like to invite the chairperson of the Umgeni Water Board. I think she's online. If you would like to say a few words, ma'am.
Thank you so much. Good morning to Team UKZN. Thank you so much. We're excited about the renewal of the championship. And I would like to thank Team Umgeni for also working hard over years to ensure that we remain relevant in our partnership with UKZN. A message from the board of Umgeni is this partnership is not only about UKZN and Umgeni, it's a partnership about the people of KwaZulu-Natal. If we look at the challenges that are there in other provinces, we tend to have a bit more unique challenges in terms of drought. Around 2017 or so, we had drought. And recently we had floods. And going back to agriculture, we have the land, but we've also had challenges around the agricultural spaces. Now, as people of KwaZulu-Natal, we need to be exemplary in how we do things. And this partnership is showing other provinces and other colleagues internationally that a water board and a university can work together for the enhancement of the work in the water sector, enhancement of the work in a province, and also an enhancement of the work in the country. Because this partnership is not only talking about water, we're talking about innovation, we're talking about research, we're talking about building people, producing a few postgraduate students is not something we can take for granted, because we are developing future leaders for the country. So as Umgeni, as Mcebo said, we're quite happy about the work they are doing in human capital development. And we hope that this partnership is even better than the first 10 years. I believe that we are in an era where research has changed in terms of its phase. We're in an era where there's more technology than technology, maybe challenges and opportunities compared to maybe what we had in the other 10 years. So I would like to see us getting more into research, innovation, and maybe technology, just to reflect the era that we are in. I would like to see us getting more postgraduate students, especially at the PhD level. We have seen that there's been a depletion of skills in the sector. And I'm very excited, and the board is also very excited. We are in for the partnership. They call it a long haul. So us as Umgeni, all we want is to enhance the partnership so that in these 10 years, we achieve even much more. Team UKZN, we are very grateful for the work that you're doing. And I'll hand over back to yourselves. And I'm very excited, and the board is excited. And I will report also in the board meeting that this is where we're going. I would like this to serve as an example for other people out there, other partnerships. They might not be in the water sector. It could be in the manufacturing business. It could be in any other business. I want them to look at this partnership and say, if we can do what Umgeni is doing with UKZN, then we can develop other sectors of our economy. Thank you so much. Thank you.
Thank you very much, Madam Chairperson, for those very kind words. I hope we can fulfill your expectations. Then just maybe moving on to some symposium house rules in terms of health and safety. I guess we should have started with this. There are two doors if any fire hazard happens. I believe the toilets are going out to your right and just to our right over here. Tea and coffee will be served to our left. I'm sure those of you who are sitting at home or at your workplace, you will find those venues wherever you need to. Can we please turn our mobiles off on silent? Those of us, or turn them off when you're here. For those of you online, if you wouldn't mind keeping your microphones off, unless you are presenting or asking a question. Please also try and turn your camera on. It's nice to see your face when you're talking, and we've got a nice big screen here that's been set up for us so we can actually see you if you do that. But I think if you are battling with and you are presenting from online, you're welcome to turn your camera off during your presentation. I think for the presenters, if you wouldn't mind just introducing yourself, just making sure we get that right. And we have got some timekeepers sitting in front here who are going to be giving you 2 minutes. And I guess for online, I'll be trying to do the same if necessary. We're giving you a 2-minute warning, a 1-minute warning, and then a 0 to cut off. We would like you to try and keep within your 10-minute presentation time period so we can have some time for questions and discussions after that. Again, I think if we can try and keep our questions till after presentation, so we are going to try and have at least a 5-minute slot after each presentation. If you can try and raise your hand, particularly in the venue, we'll obviously pick you up quite easily. Those of you online, please help me if I miss somebody. Please raise your hand online. And if you're battling to do that at opportune moment, please unmute yourself and just start talking if we miss you. So please don't feel that you're neglected online. It's just that we maybe miss something that we don't see on the screen. When you are, I think particularly for those who are asking questions, maybe just identify yourselves. I think we've got quite a diverse group here. As I was saying, I'm really excited that this is the first in contact person symposium that we've had for a while. And it is a hybrid version. So particularly if you're online, again, please just identify yourself so we know who you are. If we do lose connectivity, and we've really had one issue with our first presenter who has load shedding, and it was going to be an online presenter. So we're going to do a little bit of swapping around, but we're going to try and keep to at least the schedule. I know we've lost our time, but we want to try and keep the same sequence. So we are going to be moving around a little bit. And again, apologies again for the delayed start, but please bear with us if we have any further technical issues. Thank you. I think with that, we are in for an exciting morning. I think we've tried to group the presentations into various sectors. I guess this was particularly for those at Umgeni Water. If they were interested in a particular grouping or fields, they could just attend that particular section. So we're looking at flood studies and water supply. We've got a session on water reuse and erosion, water and sludge treatment, and then aquatic ecosystems. And then we'll be closing off with some general discussion and opening the floor to any input as well as any further questions. We will be having some breaks along the way as well for tea during the morning, as well as for lunch, and then closing tea in the afternoon. And I encourage you to stay. So we really want to use this opportunity to facilitate discussion between the academics, the students, as well as the industry leaders or the industry representatives from Umgeni Water. So I think with that, I think I'm going to stop my presentation. I think you've all got copies either online of the final program that Susan distributed to you, and we've also got hard copies in front of everybody at the venue. So I'm not going to go through those details. So I think without further ado, I'm going to stop talking and I'm going to call up our first speaker, and we're going to be doing a swap here. I'm going to be calling forward Mr. Urav Maharaj. He is speaker number 5, but unfortunately, speaker number 1 has got load shedding at the moment, and she's online. Thank you.
Good morning, everybody. My name is Siddharth Miraj, and I'm a PhD student at UKZN. And today I'll be presenting background and some results from my PhD study, which is titled The Improved Performance and the Improved Performance of the SCS-SA model and the Development of a Framework for Uncertainty Estimation for Design Flood Estimation using the SCS-SA model as a case study. And my supervisor is Prof. Jay Smithers. So I'll start the presentation off with a quick introduction to the key topics that I'll be speaking about, and this will lead into the aim and objectives. And I'll present some of the results that we have currently, and this will lead to the methodology to complete the study. And I'll end off with a discussion, conclusion, and the acknowledgements. So design flood estimation essentially associates a flood magnitude with the return period or a probability of exceedance. And with the increased occurrence of floods, design flood estimation is the prevalence of and importance of design flood estimation is quite important. So the SCS-SA model is a popular event-based design flood estimation model that is used in South Africa, although it was developed overseas in the United States of America. So equation 1 on the slide is the SCS curve number equation, which is the fundamental equation for the model. So in the model or in the equation, runoff depth Q is estimated using a rainfall depth P, the initial abstraction IA, and the maximum retention capacity of the soil S, which is calculated using a curve number, and that's the only parameter of the model. So once you estimate a runoff depth with the equation 1, that runoff depth is then translated into a peak discharge value. So the curve number that I spoke about, which is the only parameter of the model, is generally found from published curve number tables. And these tables were developed using data from catchments in America, and they were developed specifically for certain land cover classes and hydrological soil groups. So when you select a curve number from a table like this, there could be some uncertainty based on obviously how the parameters were derived. And unfortunately, a lot of the information used to come up with these tables has been lost. So the information cannot be verified, which adds to the uncertainty when selecting a curve number. So it is possible to derive curve numbers using local rainfall runoff information. And there are various methods that are available to derive curve numbers, but there's no fixed method that is used. So in addition to that, the single event-based deterministic rainfall runoff models that I use do have some limitations. So they assume probability neutrality, which essentially means that the return period of the rainfall is assumed to be the same as the return period of the estimated runoff depth. And the probabilistic nature of the input parameters and variables for these models are not taken into account. So it has been proposed that a joint probability approach can be used to overcome some of these limitations. So essentially, a joint probability approach implies that the probabilistic nature of key input variables are taken into account, and the likelihood of 2 or more events occurring simultaneously is also taken into account. And overall, with that being said, the estimation and quantification of uncertainty in hydrology has been gaining traction over the past few decades. So with that, I'd like to lead into the aim and objectives of the study. So the main aim of the study is to investigate and improve the performance of the SCS-SA model and to develop a framework for uncertainty estimation for event-based design flood estimation models, and the SCS-SA model will be used as a case study. So the key objectives are firstly to assess the performance of the SCS-SA model in terms of estimating design runoff depths. And then the performance of the SCS-SA model will then be evaluated using parameters that were derived for South African conditions. The transformation of runoff depth values into peak discharge values has to be investigated. And lastly, a framework for quantifying uncertainty for the SCS-SA model has to be developed. So in terms of the methodology that has been adopted, the first step of the methodology was to identify suitable catchments in South Africa and collect data for these catchments. So that's rainfall and daily rainfall and runoff data for the catchments. So once this was done, 11 catchments were selected around South Africa to represent different climatic regions. And once the data was collected, different curve number derivation methods were assessed. And as I said, the curve number is the only parameter used with the model. So these parameters that were derived using data from South Africa were then put into the model and used to estimate design runoff depths. So the design runoff depths were then compared to observed design runoff depths that were collected for the catchment. And this was done to identify whether the parameters actually perform well. And then in terms of the next two steps in the figure, so those two steps that's more focused on the uncertainty estimation aspect, where probability distributions were fitted to the parameters that were derived. And this was done to actually sample the parameters from a range of their values that is more characteristic of the entire distribution for that particular parameter. So this is just a overview of the results that were obtained when the derived curve numbers were used to estimate design runoff depths. So the solid blocks are the parameters that were estimated using data from South Africa. So as you can see on 9 of the 11 catchments, the estimation of design runoff depths improved when using parameters derived from parameters derived specific for the catchments. And the published curve numbers are the curve numbers that were selected for those catchments from the published curve number table that I showed. So only on 2 catchments U2H018 and G1H017, the published curve numbers actually perform better than the curve numbers that were derived for the catchments. So this shows that actually going into your catchment and using the data available to derive parameters can improve the performance of the model. So once that was done, the curve numbers that probability distributions were fitted. This was done to actually find the probability distribution that actually fitted the derived parameters so that they could be used in a joint probability approach. And what was found was different distributions fitted, for example, the rainfall and curve numbers. So for the rainfall, the GEV, which is a general extreme value 3-parameter distribution, that fitted the rainfall and runoff values for the catchment well. And for the curve number, depending on the method used to derive the curve number, the distribution that matched those parameters changed. And in terms of the coefficient of initial abstraction, which is the C value, and the IA, which is initial abstraction, those parameters were found by optimization, and then distributions were also fitted to them. So the distribution fitting becomes important when you actually use a stochastic model or the joint probability approach. So on this slide, the orange dots represent the traditional SCS-SA model, where you can see that there's one value that's estimated for different return periods. So the return period is shown on the x-axis. So the 2 dotted lines are so essentially what was done is the model was run 10,000 times, and the values for the curve number were sampled from the distributions that we found. And the 2 dashed lines represent the 10th and 90th, the 10th and 90th percentiles from those 10,000 runs for each return period. And the square block represents the median value for each return period. And essentially what you can see is when you do use the joint probability approach, you can see the variability of the performance of the model. So instead of just having one value per return period, you can see that you can represent the error bands and use the median value. And the solid black dots on the slide are the design observed values for this particular catchment. And as you can see, they fall within the 10th and 90th percentile values from the stochastic model, and the orange dots, which is the traditional event-based method that does not take the probabilistic nature of the key variables into account, actually overestimates the observed values. So in terms of moving forward, what needs to be done is the key challenges associated with uncertainty estimation needs to be highlighted, and then the different methods to quantify structural uncertainty in the model, and finalizing the quantification of parameter uncertainty needs to be done. And essentially that will lead to providing guidelines for uncertainty estimation. So just to wrap up, I just want to say that the SCS-SA model is a popular model that is used, and it has been shown that the model performs better with parameters derived for South Africa. However, if the joint probability approach is taken into account, it can result in improved performance of the model, and ongoing research in terms of uncertainty estimation is definitely required in terms of the design flood estimation. Thank you.
Thank you. Thank you very much, Udav, for that presentation. I think it was nice and clear. Are there any questions Anybody in the audience, any comments, discussion, anybody online, please just raise your hand or unmute yourself and start talking. Nobody? Maybe a question from me, Udav. So how do you see this being, your work being rolled out into practice? I think you're doing some really cutting edge stuff. What's the next step after you've finalized your results?
I think an important step would be, so as I said, to firstly highlight the inconsistencies and in terminology in terms of design flood, uncertainty estimation for design flood estimation. And once that is done, to set it up in a nice, easy to understand way, because when I first started investigating uncertainty estimation, it is quite a bit to take in, and the statistics is quite in depth. So I think in terms of rolling it out for practice, that would be something that needs a lot of focus in terms of packaging everything in a way that's easy to understand and easy to replicate.
Thank you very much. I don't see any other hands up. No hands here. Nobody online. I don't see. So thanks very much, Rudolph. Thank you. Sorry, is there? Sorry, is that Wilson? Wilson, would you want to go ahead, please? Wilson,
Thanks,
can you hear me?
Jeff, just a question on the application of the model. What I was trying to understand, is there a link between the research that you're doing and, say, the models used by disaster management or the South African Weather Services, and who do you see as the main end user of such a model? Do you need a flood modeler to run this, or can it be run and operated by, say, a catchment management agency? If you can give me some clarity on that.
Okay. So currently, we only looking at the event-based design flood estimation models. And I think in terms of application, it is the SCS-SA model traditionally is an easy to use model, and that's something we want to try and preserve, because the popularity of the model is based in how easy it is to use. So in the current, so when I showed the stochastic runs for the model, that was still running off the same framework where it's a simple model with just the curve number as the input. So I think you wouldn't need a flood modeler to actually use the stochastic model.
Thank you, Wilson, for that question. Does that answer your question?
Fine, Jeff, just a link between work or models used by the disaster management, South African Weather Services, etc.
So we haven't looked into that yet, but I think it is something that we can look into, and that is one of the ideas, to obviously develop a core framework for uncertainty estimation, which can be applied to other flood estimation models. Prof, maybe you can add in.
Maybe if I can add to that, Wilson. Yeah, so this does form part of the National Flood Studies program, and certainly disaster risk management and design of hydraulic structures and risk assessment from floods will certainly benefit from the improvements in our estimates, as well as the assessment of the uncertainty of that. So certainly this is very much aimed at the practitioner. So we really want to improving the science and the engineering and our understanding, and then move that into practice. And that does worry me a little bit, because it is quite, I think the approach is radically different to what maybe a lot of practice is used to. And I think the other issue that we have been talking about as a flood studies fraternity is how industry is going to react when we start coming up with different estimates of design floods, for example, or design rainfall. So suddenly your dam that was maybe secure for the 1 in 100-year return period event, maybe that might change if we're coming up with an improved estimate. So this is not a problem that is unique to us. I think internationally we've found exactly the same problem, where existing methods are getting updated. The old methods were used to design structures, and now with the improved methods, that has implications for the risk assessment of the existing structures that are already being designed. So that is an issue we're not quite sure how to deal with yet, and we've been looking to industry and engaging with industry to try and get our heads around that and look for some solution on how to deal with that. Thank you. Are there any other questions? I've just been informed that we're going to have load shedding here in about a minute or two's time. What is possible load shedding? I know we have got a UPS at the back, but what will drop off? Okay, I think we'll, if we don't mind, I think we can start changing over. So I think, Kanyasili, I think you're the next speaker. So we will change over, but I think can you just give us the heads up when you're happy for us to start, Ruben? Thanks. Kanyasili, if you want to come forward, we can load your presentation.
Sharing.
Okay, we're just going to wait for a minute or two, just to make sure we don't have a hiccup with load shedding and the UPS. Okay, we've been given the go ahead, so it looks like we've got through that bump. Thank you to technology, and over to you, Kanyasili.
Thank you. Good morning, everyone. My name is Umgeni, Umgeni, as introduced. I'm here to present the progress that I've made in my master's study titled Modeling, Assessment and Optimization of Umgeni Water Operating Rules for a Selected Umgeni Water Distribution System. My supervisor is Prof. Kumara Sami, and my co-supervisor is Prof. Smithers. Apologies for that. The outline of my presentation, I'll go through the introduction of my study, aims and objectives, the methodology that I'm undertaking, the literature review, modeling of the selected site, and optimization, discuss and conclude. In South Africa, water is managed and supplied by water utilities. Umgeni Water is one of the largest water utilities in South Africa. Around the world, water utilities are faced with different challenges, and and at Umgeni Water, they are expecting a 45% increase in their water demands by 2050, and they are currently using 60% of their energy just to run pump stations only, and there's high non-revenue water in KwaZulu-Natal. Also, the current operation at Umgeni Water right now is based on simple rules, just water levels, meaning they are losing out on potential savings they could have if they were to incorporate energy tariff structure in their operations. So with these problems such as increased leakages, increased demand, simple controls, they increase the total operational cost of the system and may contribute to system inefficiencies. And water utilities are looking for ways to reduce their energy, and different ways that the energy can be reduced in water distribution system. It's by modifying pumping patterns, modifying pumps, or by pressure management. In my study, I'm going to be focusing more on modifying their pumping patterns. The aim of the study is to develop a pump schedule that will aim to reduce operational cost and increase performance and energy efficiency for selected Umgeni water distribution system. The objectives of my study that I'll have to do is to review different methods of developing pump schedule and related concepts, develop an optimization problem for the system, model the selected Umgeni water system in WaterNet Advisor and IPANET, identify an optimization technique, and then use that technique to optimize the system. And then in the end, I'll evaluate the feasibility of that developed schedule in WaterNet Advisor. The methodology that I'm using, I did a literature review to check the different methods of optimization and operation of water distribution system. I'm currently modeling, calibrating and validating the IPANET and WaterNet Advisor models and optimizing the How Request subsystem as my selected site. Then I will evaluate the feasibility of the developed pumping schedule in the end. So when you develop a pumping schedule, you require data, and that data can be sourced from the SCADA system, or it can be recorded on site. And once you have that data, you will feed it into a hydraulic simulator in this case, which is IPANET. And once it's in the simulator, then you'll link it to a pump scheduling tool that will have your desired algorithm, and then it'll output a pump schedule for a specific time period, and then you implement that using the supervisory control. An example, so in literature, I found that they are opting for more multi-objective optimization methods where you have different optimization. As I mentioned, that they are currently faced with different problems, and they found a way to link those different challenges. So the optimization problem ends up having different objectives, such as minimization of operational cost, minimization of leakages, and minimizing the number of pump switches, which is interlinked to maintenance cost, and then increase the resilience of the system. On screen, I have an example of what a pump schedule will look like. This was developed by Costa and others in 2016. It has 3 pumps, and it is constrained by the tariff structure. So when the energy costs more, they opt to not utilize their pumps. And in this case, it was only one instant where they had only one pump open during a time step. And all the other time steps, they had 1 or 2 pumps operating, which led to decreased operational cost. Okay, thank you. Some of the results that are found on the literature that showed how pump scheduling can reduce operational cost. In a study performed, they were able to reduce water losses, reduced pressure and operational cost, and they also were able to increase the system reliability. Also, it proved that when there are increased demands in the system, it links to increase in operational cost. And also just adding energy tariffs, you can save about 15% in your operational cost. In terms of optimization algorithms, in recent papers that I read, the best performing algorithms I could find was the non-dominated sorting genetic algorithm, branch and bound method, and goal programming. The last 2 are mathematical algorithms, and the non-sorting is the genetic algorithm, is a population-based algorithm. So the sites that I've chosen for my study is the Hawick West subsystem under the Umgeni water system, the Upper Umgeni, and I'm currently modeling it on Ethernet. Calibrations that I've made on the system is by adding the energy cost and pattern based on Umsundozi municipality electricity rates for industrial use, and adding in efficiency curves for the pumps, and then reducing the size of the model because it tends to take much longer to run it on when I'm linking it in a MATLAB. And then I'm also going to be estimating the roughness factor age based on the age of the pipe. On the screen, it's the table shows the different roughness factors. These are typical roughness factors, and these here they show when you've accounted for the number of years that the pipe has been installed and the changes that happen. But these results are not yet conclusive, and I'm still to look into the paper conducted by the Water Research Commission for further adjustments. And then all the data that I'm using has been supplied by Umgeni Water, the data such as measured flows, reservoir levels, and water quality data. And on the graphs that I have, the two graphs that I have, they are just general observations from the data that was supplied to me for 1 week in December in 2022. In the first one, you can see the blue line, it shows variation in flow rate. And then that just proves that in operation, things are not steady. So they need to have a control pump scheduling for their operation. And then the other one shows that their reservoir levels were slightly below the minimum level of 60% that they are aiming for. And that I'm hoping to look at that when I'm doing my optimization. So the optimization problem that I formulated is that I'll look into the minimization of operational cost, increase the reliability of the system, and also put the water levels as an objective function, and it will be constrained by operational constraints and hydraulic constraints. This is just a methodology that I will follow in the different scenarios that I will have, which just includes in other base scenario is what they're currently doing right now. The other scenarios will include energy tariffs, and the other will just completely a different control where I'm just using simple time control to optimize. This is the non-dominated sorting genetic algorithm. This is just how it works. And then in discussion, modifying pumping patterns has the potential to save operational cost, and hydraulic models and optimization need to reflect the real conditions on the ground. Hence, I'm spending so much time on the calibration of the model, and the improved computation efficiency provides an opportunity for now real-time simulations and effective optimization. In conclusion, I believe that Umgeni Water can benefit from modifying their current pumping patterns and their operating rules by including the energy tariffs and reducing pressure that is in the system. Challenges that I'm facing is that the WaterNet advisor model I'm using, it cannot be accessed outside Umgeni Water network. And then acknowledge Umgeni Water for financial and technical support, my supervisors. Thank you.
Thank you very much, Kanisile, for that presentation. Are there any questions either from the audience present or the audience online? Any questions from Kevin? Are you still online?
Nothing at this stage, Jeff. I am online, thank you. But it is obviously interesting, and certainly like the literature review, and it looks like it's very interesting how it's progressing. But I don't have any questions at this stage.
Thanks very much. Lakesh? You just wait for the mic. At the back. Okay. Damien first.
Thank you very much, and greetings to everyone, especially those online as well. My name is Damien Mukansi. I just wanted to ask you something, Kanisile. You speak about reduction of pressure. what
Yes.
impact will that have on bulk supply if they do end up reducing the pressure? Thank you.
Okay. When I'm doing my optimization, I will have a constraint that would have the minimum pressure required to meet their water demands or to supply the necessary water. So you may find that the system sometimes operates with pressures that are higher than required. So that pressure that is reduced, it's that pressure that is being used without having any effect in the reliability of the system. So since I'm having reliability, optimization ensures that the problem is constrained, so you are not further affecting another aspect of the system.
Thank you. Does that answer your question? Please go ahead.
Good morning. It's Lakesh Maraj. Umgeni Water Operations. Kanisilia, thanks. Good presentation. This is just more of a comment, and it's also for the modeling teams. I think it will follow for some of the modeling presentations that are coming. I think Umgeni Water, currently we on a project for 3 of our major water and wastewater works. So 2 large waterworks and 1 wastewater works, where we're looking at full automation, digitization. So all of these modeling models that are being developed by university, and it follows from what Wilson mentioned about application. So I'd like you all to cover a little section in your thesis or your dissertations around the application, the training, and how could we adapt it? Because as we advance in this full automation, we'll come to a stage where we need to test some of these models. So the early warning systems that were discussed earlier, we're talking about the predictive modeling, data analytics. We may at a stage look at digital twins, so we would be able to, using the live data, test some of these good models that you've proven that they work. So I encourage whoever presents even after you and your colleague before that, yeah, we'll be looking for these models, working models, and applicable to what we're doing. In your case, there's a lot of constraints, as the previous speaker highlighted, in terms of supply and demand, the pressures in the network. So our colleagues, I think you are collaborating with the colleagues,
Yes.
yeah, internally. Like I think that's where you'll be able to identify more of the challenges. And if you could incorporate those kind of assumptions and in your model, it'll be more of a true reflection of what we really face, and then that'll help you with your energy. But just from just in terms of modeling, just wanted to highlight that all of these models, at the end of the research, we hope to receive these working models. So, and how can it be integrated into PLC, Allen Bradley, for example, and work with MATLAB, Simulink, whatever it is. So a section that covers that will help us later if we want to test it. Thank you.
Thank you so much for your comment. We'll take it into consideration.
Thanks very much. I think that's very, very wise words for us to take into account. And that's certainly that we wanted to do. We are not doing necessarily blue sky research. We want research that's going to have impact on the ground. And that's why I think the collaboration and cooperation between Umgeni and the university is essential for that to happen. Thank you very much, Kanisile. I think if we can move on to our next presentation then, can I just confirm, is Joel here? Joel, good. Good morning. Can you please come forward, Joel, while I start your presentation?
It looks like that's an older one, right? another one. Sorry, I updated my slides, but she didn't send you another. Because she asked me to update. Okay. All right. Right. Good morning, everyone. My name is Joel Kalala. I am a master's student from the University of KwaZulu-Natal, and my supervisors are Prof. Kumar Sami and co-supervisor Prof. Jeff Smithers. My research topic is titled Optimization of Cement Mortar. Can you hear me? Yeah. Right. Optimization of cement mortar mix ratio for water distribution pipes using silver nanoparticles. All right. So for the presentation, I'll be looking into giving a bit of a background and introduction into the study. We'll look at the aims and objectives of this particular experiment because the topic is a little bit broad, and so we have parts of experiments that we're doing. We'll address the methodology and results and conclusion of our findings. All right, so the first point here is biofilm growth in water distribution pipes. So what we currently are experiencing, especially in South Africa, is water quality challenges. And we often have cases of reports, for example, in certain facilities where we may have water-related diseases, for example, gastroenteritis cases. And when we do ask officials, for example, and ask for inquiries in companies, for example, Umgeni water, and after certain tests, we see that the water quality is all normal. For example, we'll have returns of low turbidity, or we can find that no microbiological issues are found. And so that tells us that in between the treatments of the water and delivery, there may be something occurring in which, although the water quality is perfect, we may still have certain contamination occurring within that transportation. And the first problem that we are looking at is reducing or limiting the control of the growth of biofilm or microbial accumulation within pipelines. And so we are looking at optimizing the cement mortar lining, because the cement mortar is one of the best or chosen methods of lining material used within distribution pipelines. And biofilm accumulation that occurs on that surface, obviously after a certain period of time, introduce changes in wall properties, as well as roughness and frictional factors. And so frictional resistance. And so we have eventually issues such as hydraulic performances, hydraulic inefficiencies that can occur, and of course, waterborne diseases. And so hydraulic implications will also look at how the growth of microbial contamination within pipelines are affecting our pumping stations and the efficiency of our hydraulic systems as well, in terms of power demands and power demands as well, and how much power can be throttled back by perhaps optimizing that surface, cement mortar lining surface. And so we're doing that by incorporating silver nanoparticles, which is latest technique that has been introduced in industry, where nanotechnology is being used quite a lot, and this includes nano-sizing certain metals. So research has shown that some of the most famous nanoparticles that have been used are nanosilica. We've had zinc oxide. And for this research, we are experimenting with silver nanoparticles, because over the years, and they've shown very good antimicrobial, they've been used as very good antimicrobial agents, and also used in many industries as well, for example, in the textile and also in the medical industry as well. And so we are looking at incorporating nanoparticles within the mix of cement mortar lining. And in doing so, we are essentially tackling three problems or so with one solution. So the first one would be to limit and control the growth of biofilm within water distribution pipelines. And the second implication as well is to see what kind of mechanical performances or advantages that we can get from that. And we'll see how that applies. And so the aims here is to, the aim, of course, is to investigate if the effects of silver nanoparticles within cementitious composites. We also investigate changes in mechanical properties of cement mortar samples. And also we will look at analyzing the implementation costs as well. For example, if we decided to give it a go, what that would look like in terms of pipe manufacturers and changing the whole preparation and preparation of cement mortar linings and pipes as well. And so for this particular experiment, so what we're doing, if we've selected a couple of concentrations, because in my previous research, I experimented with one concentration, and we show that through microscopic analyses that silver nanoparticles did have a very positive effect in retarding the growth of biofilms. And so for the following steps is we increasing that concentration a little bit just to see if we can find an optimum point, because we'll have issues such as toxicity levels as well that we have to deal with. And so the first step in the methodology would be to synthesize and prepare silver nanoparticles. We're using a chemical method. There are several methods that are proposed. And so we're using the chemical methods, which is a lot more cost effective and a little bit easier as well in terms of because we also have to consider implementation. How would pipe manufacturers include such a new step into their manufacturing? And second step is preparation of samples, and so we're testing strength, compressive strength, and tensile strength for certain curing ages. So we had 7, 14, 21, and 28 days of curing, and so at each of those curing ages, we're performing strength tests on our samples, of course, infused with different concentrations of silver nanoparticles. And so we're using a universal hydraulic machine, hydraulic machine there. And the tested samples as well I included this picture because it shows a very nice hourglass type of failure, which is positive as well in terms of showing how the stress distribution occurs at the center of the samples, which also confirms that the recommended mix ratios as well, for example, water cement and sand and cement are also are the right ones. Okay. And so the results show that we have a linear increase. We had a linear increase in strength. And so in lower strength at early stages, we had, so for all testing samples, all concentrations, we had a positive increase in mechanical strength. This is compressive, as you will see, as well as the control versus optimum. So we look at between the 9, 15, and 21%. 9% showed to be a little bit more effective, which is also positive because later on it is good because we can see which of the concentrations provide a bit more cost-effective solutions to this issue. And split tensile strength as well has been we also discovered. We got that from equations, models that are just simple transformation models just to get split tensile strength, to understand as well internal stresses, because underground pipelines tend to experience a lot of internal and external stresses as well. And so tensile strength was also a very essential thing to experiment. And so the maximum strength gain that we saw was 28 days for at almost 10% increase. We had about 10% increase in strength. And at the bottom here, I was just noting the different parts of the preparation that are required. which silver nitrates as the official the official source of silver. And so so the findings, as we saw, enhance material strength to the densification of the cement matrix, because silver nanoparticles tend to, at the nano scale, have high surface areas. So that's able to densify the cement matrix and reduce porosity as well, which gives us good strength for long term. Optimum concentration is 9%. And the implementation and cost analysis that will we spoke to a couple of pipe manufacturers, and due to cost analysis, the majority of the costs will heavily depend on the preparation and the synthesis as well. And so we're trying to make that as simple as possible to see, in case of implementation, how that could look. And later on, as part of the experiments as well, we incorporating toxicity studies to understand how much toxicity can be expected with such implementation. So, yeah, thank you.
Thank you very much, Joel. Thank you. We've got a question from the floor. Can we please have the microphone?
Oh, thank you, sir, about your presentation. I'm concerned.
Could you please just identify yourself? Sorry.
Oh, my name is Nkosinathi Madlala. Yes. I have a question in terms of toxicity, as you outlined at the end of the presentation. Because I'm just reading the article now, and it came to my mind when you were beginning presenting, which you are working with silver nanoparticle and stuff to solve whatever problem that we are presenting. But I think we've seen in this world now, we have a lot of healthy implications. And we tend to see which the earth is depleting in terms of human and environmental factors, because we are using more synthetic things. While come to solve other problems using organic and sustainable ways, you don't have any option of synthesizing those nanoparticles to replace with the silver that you are using, because silver, it's quite toxic once it reaches human cells and stuff. Because in the industries, cloth industry, food industry are using it, but there is a proven research that it has a serious healthy implication, cancer and all those things. Since we see the state of cancer, people are dying with cancer because we are using more of synthetic things. I was hoping, because in this 21st century, we have a lot of problems. So why can't you move to sustainable and use something that is organically derived? Yes, thank you.
All right. Thank you for that. That's a very good suggestion. We'll also look into that. However, silver, with experimenting or looking into silver and its health effects as well, we saw that essentially we'll always have leaching, all right, because the silver is being incorporated within the cement. And the only way we can have contamination is if somehow those silver ions are leach off the surface of our pipelines. And so what we'll try to prove is how much of that is being leached off, because we essentially always have leaching when incorporating anything, even cement itself as well does leach us at times as well. So we will look into synthetic options. However, silver, yes, it is highly toxic, as we've said. However, that toxicity is dependent on many factors, such as environmental conditions, and which is why we will try to simulate different environmental conditions within the pipeline, such as pH and several others, to see how much toxicity we can get.
Thank you for that response. Wilson, I see you've got a question online. Can you please go ahead? Let's get Wilson first.
Thanks. My main concern with the proposal is related to the economic viability of this proposition. Given the scale that we're looking at, for instance, a 600 pipe running 30, 40 or more kilometers, what do you think would be the implications in terms of cost? I know that's still underway. You did indicate you're looking into this, but I think it's something that we were concerned about at the outset, and it was raised previously. So if you had given it a little more thought and can comment on that, thanks.
Okay. Yeah, so on cost analysis, so from pipe manufacturer, we spoke to 2 pipe manufacturers, and we even got some quotations and asked them to give us a certain idea of what the implementation would be like. And so for the synthesizing of silver nanoparticles, it's the majority of the cost will come from the source itself, which is silver nitrate. And silver nitrate is found to be, we can reach those concentrations with very limited amounts, very, very tiny amounts, especially with the synthesizing method that we've chosen. And that's also one of the reasons why we chose the chemical method as well, because that seems to be using very small reagent chemicals such as sodium hydroxide as well, and silver nitrate, which is a source very in limited quantity. So the majority of the additional cost that would be required or that would be added onto the manufacturing would from the pipe manufacturers themselves as well, would come from the silver nitrate cost, and as well as the synthesizing, depending on whether the manufacturers themselves synthesize it or we try to get that externally.
Thank you very much.
Yeah.
I think you need to take note of the, we come to Matthew in a minute, but just we need to take note of the comments coming from industry and the concerns. So thanks for those. Thanks very much, Wilson. Matthew, can you go ahead, please?
Okay. Yeah. No, thanks, Jeff and Joel. It's Matthew Bennett from UKZN here. Just from a zoology or biological perspective, so the accumulation of biofilm in these pipes, there will be some exposure of this biofilm to the silver in nanoparticles, and that provides or causes a toxicity which kills the organism, but it will accumulate in that biofilm. And so in accumulating that, not only the leaching off the pipe into the water from the nanoparticles, but also then the accumulation in the biofilm that then potentially flakes off, or as those biofilm deteriorates and dies, has to reach a certain toxicity before it will kill the organism. So I was just wondering if you guys have actually looked into that in terms of contaminating the water source. I know a lot of heavy metals in low concentrations are used to treat water. There's a degree of a level of acceptable risk, but yeah, it's at the same time it would bioaccumulate in the trophic levels. So as we drink this water more and more, the silver will bioaccumulate in us, which then gets to a point of toxicity for us as well. So I was just wondering about that.
Yes, that's correct. We have looked at that, and the solution, of course, well, there isn't really a such solution at this point. But what we found is that the level of toxicity, of course, will be dependent on the environmental conditions within the pipeline, as I said. So within the water column itself, once the silver leaches off, we'll have to make sure that through our leaching experiments that we'll be conducting, that we're meeting the requirements, as you said, of heavy metals allowed within the water column itself. So we have a certain standard that we'll be looking at, and whether the leaching off reaches that or not, that's kind of what will direct our decision in terms of how much of that will be accumulated within the film itself. So, yeah.
Thanks very much, Matthew. Yeah, it's another word of caution, I think. So just really think about the big picture and the implications of the potential outcome. Thanks very much, Joel, for your presentation. Thank you.
Okay, thanks, Prof. Thank you.
Ladies and gentlemen, we are running behind schedule. And I think with your permission, I don't see anybody from the caterers here or from the venue. Are they? I think we should probably have our tea break now because we're way over the time we gave them. So with your permission, can we go ahead and have our tea break now? And Nilasiwe, we'll start with you straight after tea break. Can we have about a 12-minute tea break? That'll take us back to 10:50, so 10 to 11. So everybody online, please get up, stretch your legs, grab something to drink. We're going to do the same here, and then we'll all be back together at 10:50 sharp, and we'll try and keep to that, please. So thank you very much for everybody, your participation so far. Thank you to the presenters, and then we'll continue at 10:50. Thank you. Sometimes you just gotta, relax.
So that's about company. So like, I mean, you can probably realize that.
And this is 20 foot report. Yeah. So we have done so March. Yeah, end of May, March. That is fine. The house is sold. Oh, okay. Because I advertised on my Facebook. About 5 or 6 people to buy it. And I told them they must. What I told them is that once I buy it, my market down is 400. Yeah.
Hi, how are you?
I heard all of you thought that they received.
Put a face to the name.
Yeah, yeah. Okay, all right, yeah. Why? Just want to demand. We'll see where you're next. Number 4, right? Please.
Yes. Just nervous. Oh.
Yeah. And the controls are. Let's see the control. We can't see the controls. Which one? What do we do? Right. Yeah. Something that's in Zoom control.
Sometimes it goes into 2 modes.
I need to get
Then go to duplicate after that.
Yes.
Go.
Okay.
Right, welcome back. I think we need to make a start. We are running again behind time. So hope you all online. Hope those of you online, maybe we'll ask you to put your cameras on a little bit later to make sure you're still there. Hope you've enjoyed your tea break. We had to rush through ours. Yeah, I think it could have continued for quite a lot longer, but I think we need to go on with our next presentation, which is going to be done by Nelisiwe. Over to you, Nelisiwe.
Thank you, Prof. Good morning, everyone. Once again, I'm Nelisiwe Kusi, and today I'll be presenting on the application of an openly available flood damage assessment model in South Africa, a Montego case study. The project is supervised by Ms. Caitlin Anna Johnson and co-supervised by Professor Smithers. The consideration of flood damage, the quantification of flood damage forms an integral part of flood risk assessment and management. It is very important for developing policies for reduction and prevention. However, in developing countries, flood damage assessment methods are poorly understudied and poorly implemented. And due to lack of technical capacity, funding resources, and institutional capacity. Moreover, the methods are outdated, which overall results in modeling tools and flood damage data being unavailable or of poor quality. In South Africa is no exception. Even though there were models that were developed, namely the flood sim and the TUA model, the models were based on an outdated operating system and they were never updated. Therefore, they are no longer available for application. Therefore, exploring alternative methods for application provides an opportunity to overcome data limitations and model limitations. Therefore, the aim of this study is to evaluate openly available data sources and modeling tools for flood damage assessment and to demonstrate how flood damage assessment can be conducted in South Africa using the available data. And to achieve this, the following objectives need to be met by conducting a literature review of the models available, looking at the different types of models and the minimum data requirements, conduct a feasibility assessment in order to determine the available data for flood damage assessment in South Africa, and adopt a suitable model taking into account the South African context. With this in mind, a review of models available was conducted, and the following criteria was considered when reviewing these models internationally and models that are available locally. The input data requirements, the model availability, its applicability, access to technical support, and its suitability to support local context. By local context, I mean, can we use the model to assess damage here in Sunduzi, and can we also use the same model in other areas like Free State or Gauteng? The scale of application, can it be used nationally or locally? The unit of analysis, can it be an object-based or land-use-based? And the type of damage that's assessed. The criteria was then used. No, I need to move to the next slide.
Next slide.
Yes. Okay. Then the following model review was used to select a suitable model. And the reasons for rejecting or accepting a model are provided in the following slide. The flood risk model was selected mainly because it's flexible and can use different data sources, can be applied at any different spatial scale, enables us to use land use based analysis or object-based analysis, and it's freely available as a QGIS plugged-in model. Further answering the question whether how can this model be applied in the industry, it's now and then updated. It's freely available, therefore, and it's easily to understand compared to other models. The following slide provides the basic methodology for the flood risk model, which consists of 3 components: the hazard component, the exposure component, and the vulnerability component. For today's presentation, I've only outlined the data acquisition and methodology for the hazard method. To evaluate the model, we need to compare the estimated values with the reported values. Therefore, we need to go and look at a historical flood event where reported impacts were assessed to compare with the estimated values of the estimated values using the model. Therefore, prior to this study, a standardized national database was developed, taking into account flood events from 1900 to 2019. The onset and the spatial scale and the duration of each flood event was considered, and historical data on each flood event, taking into account the recorded rainfall, peak discharge, or the estimated return period were taken into account, and the reported number of people were affected, fatalities, or the sectors that were affected in rand value, and if whether warning systems were issued before the flood event were also documented. Overall, over 824 flood events were documented, and KZN had the highest number of documented flood events compared to other provinces. Taking this into account, a case study within KZN was considered, such as the 1987 flood event. However, when taking into account the available data on the impacts, it would state that the number of areas that were affected, such as Umgeni or La Lucia or Pietermaritzburg. And then on the impacts, it will say over 600,000 people were affected and over 300 fatalities occurred, without actually specifying where these fatalities occurred or where were this number of people affected in which area. And the reported estimated costs were provided as a total estimate, not providing estimates maybe where in the total, in which sector is the estimated impact. Therefore, alternative case studies needed to be sourced, and an alternative case study that was sourced was from the Western Cape, where a detailed post-flood damage assessment was conducted and specifying which area was affected, the sectors that were affected were identified, the number of people which were affected were identified, and the area which the flood event occurred was clearly demarcated, enabling us to conduct a flood damage assessment using the model. Fortunately, there were no fatalities as a result of this flood event. Montego is located within the Western Cape. Therefore, to conduct hazard analysis, the hazard analysis consists of two aspects, such as the hydrological analysis and the hydraulic analysis. For hydrological, we needed to determine the peak discharge, and for hydraulics, we needed to determine the maximum velocity of the area, warning time, and the depth of the area. For peak discharge estimate, I used in this case study a slope area method was used to determine the peak discharge of the event, and I used the deterministic and empirical approach to determine the peak discharge, and the value closer to the reported value was selected, which the method used was the Kappa method, which was used. And once I have conducted hydrological analysis, a 2D unsteady flow analysis was conducted using the HECRES model to determine my maximum velocity, depth, and warning time. Overall, I have indicated that the Kappa model was used to determine a peak discharge, and the HECRES model was used to determine the maximum velocity of the area, the warning time, and the depth. And I indicated that while KZN had the highest number of flood events, there were no case studies where detailed flood damage assessment were conducted. Therefore, an alternative case study needed to be sourced, which is Western Cape. Now that I've conducted my hazard analysis, the following, I will therefore conduct an exposure analysis and vulnerability analysis, in which for my exposure, I will determine the elements at risk, which I will need my land use data and infrastructural lines and the asset values of the land use within the area. And for loss of life assessment, I will need population data and population density. Once I've conducted my exposure data, I will then conduct vulnerability data, which requires depth damage curves and fatality rates, and once I've which are relative depth damage curves. This is where I am so far with my project. I'd like to acknowledge the WRC and Umgeni Water for funding, my supervisors for support, and Offense and Mr. Ernest Oaks for assistance. Thank you.
Thank Thank you very much, Nilasiwe. I'd like to open the floor for any questions or comments. Anybody present or anybody online? Thank you. There's a question up front.
Yes, thank you. Again, my name is Gosnati Madlala. So I just want to ask the question, since we are facing currently with floods in different locations, you can see from KZN, Limpopo, Mpumalanga and stuff, Eastern Cape. So this thing is changing, like is moving from along the South Africa coastal line. So can you maybe give me a scenario? How can you use this model, even though I'm sure we are not complete with it, but on your mind as you are working on a project, how it could be effective in solving this current issue that we are having, especially these people who are in a disadvantaged background, who are not have enough data in terms of floods, warnings and stuff. Even our water weather service, they are failing us, we can see. But how can this model can be, just a short scenario, how can this model can be, this model that we are working with, how can they can be effective in trying to elevate this situation?
As indicated, that the model is vital for flood risk assessment. So with risk assessment, with the type of models that I've been using so far, we are able to model areas that are at risk of flooding or are vulnerable of flooding. So once the areas are identified and there are maps that are mapped, there are maps indicating areas where a flood event of areas that will be affected if a flood event of a 50-year flood, of 100 or a 50-year flood event were to occur, which areas will be most vulnerable. So the maps enable, with the map, it will be easy for people to identify if my area is at higher risk of flooding or not at higher risk of flooding. So with this model, we'll be able to produce maps indicating areas that will be most likely to be affected, which will be easy for community members to understand just by looking at the areas that are flooded. And should a warning system is issued and it's stated that it's a 1:50 or 1:100, a community member will be able to understand that since it's a 1:100, more likely will be affected by the area, and they can implement prevention methodologies to prevent themselves from being affected or being faced. Yeah, that's all.
Thanks. Thank you. Any other questions? Anybody online? I don't see any hands up. If not, thank you very much, Nilasiwe. I'm just going to stop sharing. I think our next presentation is going to be done by Zama. Zama, are you online? Yeah, you are. Can you please go ahead and share your screen and introduce yourself and start your presentation? Let's just check it's going to work. Okay.
Can you see my screen?
If you can go into slideshow mode.
Yes, I did.
Can you put your video on? Is your connectivity good or not?
No problem. I'm afraid that it will hamper with this thing. It will affect my audio.
Okay, please go ahead.
Good morning, everyone.
I will be giving you sorry, Zama, I will be giving you a 2-minute warning.
Okay.
Thanks.
Okay. Good morning, everyone. I'll be giving a brief presentation on my MSc project, which was titled Assessing and Improving the Simulation of Runoff and Design Flood Estimation in Urban Areas using the ACRU and SESA models, supervised by Prof. Smithers and Ms. Ione Lewis. So I'll take you through the introduction and a brief background of my project, the aims and objectives, the methodology, land cover classification results, the model simulation results, and lastly, the discussion and conclusions. So the threat of the recent floods that have hit part of the Gauteng and Northwest provinces, affecting, I think, more than 40,000 people, as well as the previous floods, such as the KZN floods, has emphasized the need to update existing design flood estimation methods to make them more robust so that we can see these floods coming and therefore prepare by improving the design and capacity of our stormwater infrastructure. And it therefore makes sense to focus design flood estimation in your usually more vulnerable catchments. These are your urban, peri-urban, and informal settlements. The vulnerability of these catchments is usually as a result of the catchment permeability, drainage parts, and the state or lack of stormwater infrastructure, to name a few. And there's obviously a need to update existing approaches to design flood estimation. And one way to do this is to develop a sort of an interface between GIS and remote sensing with hydrological modeling, where the two are mutually beneficial to each other. The aim of my research project was to evaluate and improve the performance of runoff simulation and flood estimation in urban areas in South Africa using the ACRU and SESA model. And to just summarize the objectives for my MSc was to basically use GIS and remote sensing to estimate ACRU parameters, more specifically urban impervious parameters, with the attempt to improve the simulation of runoff in urban areas. My methodology included selecting urban study catchments, collecting ACRU and SESA input data, and exploring different remote sensing and impervious mapping methods, which was then used to accurately estimate ACRU's adjunct and disjunct impervious components. After collecting all of that data, I then configured the models and then ran them for the collected data and analyzed the runoff simulations under urban conditions, and then lastly assess the performance of the models when applied in complex urban areas. I worked with 3 urban study catchments. 2 were located in the Gauteng province, and 1 was a local catchment located in KZN in Pietermaritzburg. So I conducted the pixel-based land cover classification method to map out the total impervious areas of my study catchment, and then use that total impervious area to estimate ACRU's adjunct and disjunct impervious components, which are crucial when modeling an urban area in using the ACRU model. One of my objectives was also to look at how has urban development changed over the years, and the link between that and the increase or decrease in impervious area, and how that and what influence does that have on stream flow generation. Moving on to my simulation results. So I looked at various impervious mapping methods. The pixel-based land cover classification method was conducted specifically for my study, for my project. And then I also looked at alternative sources of impervious data sets like the GMIS and the GAIA. So these are global impervious data sets. I also looked at the default values which were derived by Tarberton and Schulze from the ACRU model. So they estimated impervious fractions, and Lutz and Smithers also estimated impervious parameters for the Gauteng catchments. So I then ran runoff simulations using the ACRU model for these, parameterizing the model using these impervious mapping methods. And I found out that the pixel-based and the GMIS impervious mapping methods produced better runoff volume simulations compared to the other methods when compared to the observed graph. Based on the peak discharge simulations, the ACRO model appeared to have simulated the flows better, which goes to show that if we invest more work on improving the accuracy of the input data or input parameters through the use of GIS and remote sensing, we can actually improve the simulation ability of design flood estimation methods or design flood estimation models in this case. And then to conclude, I realized that during the course of my study, obtaining satellite images with fine resolution in order to enable accurate land cover classification was quite a challenge, especially obtaining satellite images dating back to the 1980s, which was when I started my simulation period. Another challenge was conducting thorough field land cover classification verification, as one of my study catchments were inaccessible due to protest and safety issues. It was noted that impervious land cover components of the catchments introduced quite a significant oversimulation of both volumes and peak discharge. And there is a need to update and improve the reliability as well as the consistency of readily available climate and land cover databases to simplify the modeling process. So as most researchers and postgrad students know, that this is a very, it gets really dreadful to collect data as well as sort it out. It takes a lot of time, and therefore it delays project progress as well. The ACRO model proved to be a comprehensive and data-intensive model, and the SESA model was more user-friendly but not explicit enough. The ACRO model produced over-simulations of runoff volumes in most cases. The observed data that was fed into the ACRO model had to be thoroughly investigated in order to improve the runoff simulations. And the SESA model simulated runoff well, but it did over-simulate peak discharge as seen in the previous graphs. I'd like to acknowledge my supervisor, Prof. Smithers, as well as my funders. Thank you. Prof, I can't hear you.
Thank you very much, Zama, for the presentation. I'd like to open the floor to any questions or comments from the floor. I don't see, can you stop sharing, Zama, so we can see the people online? Thanks. Any questions online? Don't see anybody. Any questions here? Maybe just a quick question from me, Zama. So if having worked intensively with these two models, what would your recommendation be for the future?
My recommendation would be to, I think firstly would be to make sure that there's a standard process when modeling urban catchments using the ACRO model, because in terms of parameterizing it, especially the impervious components, there's usually a bit of a discrepancy or a confusion. So if we were to ease and have readily impervious data available, that will really ease the process in terms of modeling urban catchments, particularly in using the ACRO model. That's what I would recommend. Thanks, Parth.
Thank you very much. I think on that point, let's move on to the next presentation. So Joash Kirsten is not available, but he has sent us a video clip which I don't think we're going to play now. We haven't included in the schedule, but we will make it available. So you're welcome to watch that. So I think all the students who are not able to present either online or physically at the event will be also preparing a video clip to include in the distribution. So let's move on to our next presentation then, which is by Damien. I'm going to hand over to you, Damien. Just get out of this. What else do I have to do? What is it? Share, sorry, okay.
Thank you very much. Greetings. Once again, my name is Damien Mukansi. And maybe even before I speak about the title of my presentation, as you have seen, the previous speakers have alluded to certain things. For instance, they make use of ACRU as well as the SCS model. All these models that they are using assumes that your hydrological process remains stationary. So as you might have seen, Mr. Maharaj indicated that you have curve numbers, which are influenced by factors as your initial abstractions, which are influenced by land cover. So if you look at a real catchment, you have changes in land cover. You already, by that, you could already challenge the assumption of a stationary condition. We have things such as climate change, where we are assuming that we are going to be experiencing more intense, frequent extreme events. So therefore, that leads to my title, which is Detecting Trends in Hydrological Extremes, as well as incorporating non-stationary models in design flood estimation. I'm supervised by Prof. Smithers. The presentation will highlight the introduction, literature review, aims and objectives. I drew a preliminary study in Umgeni catchment, where I'll discuss the selection criteria, results of your record length and homogeneity test, results of your time series trends, Mann-Kendall test, results and modeling. And therefore, and then from there, I just speak about the proposed methodology moving into the future. So detecting hydrological extremes is vital for adequate design of hydrological structures such as dams, spillways, and culverts. However, the current methods which are used assume that your hydrological process remains stationary. This means, but there are studies which are showing an increase in both your magnitude as well as the frequency of hydrological extremes. I must highlight though that currently we still also don't have concrete consensus. Therefore, there's a need to evaluate trends in South Africa as well as incorporate non-stationary models. Where will that be used? In the various design models that are currently being used in industry. Just a little background. So in stationary assumption, the probability, the parameters of a probability distribution, such as your normal, log normal, Pearson type 3, are assumed to be constant. That is to say your mean, your standard deviation, and other parameters are assumed to not vary as a function of time. We also see in literature that 3-parameter distributions give a better estimation of the observed. But when you link 3-parameter PDFs as well as your log normal trends, it yields very complex non-stationary equations. Therefore, to generate simple non-stationary models, one could recommend your log normal. So in a stationary models, the parameters are assumed to vary as a function of some covariety, such as time, rainfall, and any other factor which is a driver in your hydrological systems. I'll just highlight just a brief explanation in table 1.1. As you can see there, you have various distributions. Some are 2-parameter distributions. You have your GV, which is a 3-parameter. You can use non-stationary for a range of variables. It could be river discharge, it could be rainfall, it could be temperature. But this is where the focus is, where we look at varying the model as a function of some parameter. And these are the covariates that you could use depending on what you think is a driver. It could be land cover, it could be time, it could be temperature, it could be rainfall. Therefore, this leads us to the aims of the study, which is to determine trends in hydrological extremes in South Africa. For this presentation, I will just focus specifically on Umgeni catchment, as well as to incorporate non-stationary hydrological data into design of flood estimation in South Africa, just to ensure that we design our hydrological structures adequately, because even roads are designed for a particular return period. And if you are going to be having that more frequent as a result of non-stationarity, then there is a need to actually evaluate the current existing models. The objectives of the study, with the first one highlighted, because that's the aim, what we are looking at today, it will be to incorporate non-stationary data in modeling design flood estimation. It will be to determine trends in hydrological extremes as a result of anthropogenetic factors. So we're not looking at what the factors are. It could be climate, it could be land cover, it could be various factors. Then we'll then look at using regional magnification factors to quantify the magnitude of these trends. We'll investigate links between your projected climatic models and compare this to observed trends in flow data. And lastly, we'll evaluate or assess risk to already existing structures as a result of non-stationarity. So what does non-stationarity tell us about already existing structures? So I then did a study for Umgeni catchment. It has a total of 31 DWS rainfall stations and 4 dam inflow nodes. The red dots are those ones that met the selection criteria, which I'll go through briefly. If you look at the selection criteria that is going to be used, we are adopting the same that was used by Nathaniel and Kurtz here in UKZN. So, however, we modified the record length from 20 years to 40 years. That is influenced by just looking at the mean record length for most studies. It's around 40 years of record that we have. So negative and null records will be discarded. Missing annual data that are more than 3 months will also be discarded. And if the recorded depth of flow exceeds the rating table, we will then extend to a maximum of 20%. We are also doing a review on the 20% because that influences uncertainty. So there is a possibility to changing that depending on what we end up finding. From there, you could see of the 31 stations, only 10 stations met the selection criteria that was used by Kurtz and Nathaniel. And in this particular study, you could see that there's a couple of studies with less than 40 years where we did not do an analysis on them because we chose 40 years as the record that we are looking for. We then did a homogeneity test using a PT test. So what the test actually does, it tries to detect any changes in your mean and assess whether you don't have hydrometrics in your structure. So these are influenced by an instance where there was a change in your gauging system, or there are errors in terms of changes in your rating curves that are being used. So you don't want to detect a false change and say the change is a result of non-stationarity, only to find that it was just changes of your rainfall station. So that's what the method helps us. So what we then did is it detects a split, and it tells you in 1978 you had a split. And looking at that, we looked at the record length. If the split happens, for instance, these ones were not further used in the study because the split happens in the center where the record before and after is less than 30 years. So what I just wanted to also highlight is just a time series trend. You can see that majority of the stations in Umgeni show a negative trend. And I also wanted to highlight that if you look at most of the time series trends, you have this peak in 1987 there. So we're thinking it's possible that you have mixed distribution where you don't have a single distribution, but you have double distributions, maybe from a convective storm as well as a cyclone, for instance, a rare event. So this was just to show the importance of performing a split, where you can see that if you did not perform a split, you would have assumed a positive trend. But by just doing the split there, you can see that the remaining record length actually displays a negative trend. We then did a Mann-Kendall test. The Mann-Kendall test just shows us that you get a lot of negative trends within in Umgeni catchment. In fact, all stations showed a negative trend, majority of them not being significant. But the fact that there is a trend gives rise for us to even do this particular stationary analysis. And if you compare graphical of the two, you see there was really no distant results between non-stationary and stationary. But if you look at the effective return period, which is what you need for design, you can see that there is a reduction which is consistent with the negative trends that you were seeing. So you can see that over the years, the values of the 100-year return period is reducing. So just looking at the other selection criteria, such as the IAC, BIC, I can conclude that then the stationary model actually did better than the non-stationary for all stations except the Midma Dam. So in conclusion, the trends in Umgeni catchment are negative. The stationary model gives better estimation of the observed. The presence of trends, though, gives reason for a need to investigate further. So what we will then do, we'll then try and look at collecting data across the country, screening of the data, assessing for trends, doing an analysis, and then this will be the next stage where we actually assess the magnitude of the change. So we said it wasn't significant, but how big is that significance that we're talking about will be the next phase. Thank you very much.
Thank you, Damien, for that quick overview of your study. Do we have any comments or questions from the floor or from online? Maybe a quick question from me, Damien. Kevin, yes, please go ahead.
Thanks. I just wanted to question, obviously it's showing a negative trend, but that I know at the end of the day, what we're looking at is extreme value distribution or analysis, and you're looking at floods ultimately, but a lot of that negative trend looks like it's in the low values. And I mean, surely that can just be attributed to more water being taken out of the rivers for irrigation or something like that. You know, maybe the trend in irrigation and the catchment could be compared against this. You could have a look possibly at what the licensing values were, you know, a number of years ago versus what they are now, to see whether that's actually the cause of that decreasing amount in the rivers. Just a comment.
Yeah, I think maybe just to actually add there. So that's something that we actually looked at. So there's a parallel study that's looking at rainfall, but in other regions. So we were also expecting that we want to see an increase in trend, and it's all making sense in our heads that we're expecting an increase in trends, but the rainfall as well is also showing a negative trend. So I think we are also going to look at such factors as land cover, because in Umgeni catchment, we could correlate that to factors such as there's better agricultural, like people, there's a lot of farming happening around, so a lot of abstractions, and there've been papers done in that area. But when you start looking at the rainfall, you get a little bit nervous. So there's a lot of work that needs to be done. So we are trying to correlate the rainfall as well as what we're seeing in floods. But I can also assure you that one of the core variety that we'll look at would be how it's influenced by rainfall, not just how it's influenced by time, as we did in this particular passage. Thank you.
Thanks, Kevin, for a very relevant question that certainly is puzzling us. So both in terms of rainfall as well as floods, we're actually seeing a decrease in the annual maximum series, which is, I guess, floods we can explain, as you say, by abstractions and impacts within the catchment. Rainfall not, because all the climatologists and the climate modeling are telling us we're going to be seeing increases. But I think we do need to dig deeper than just having a look at the annual maximum series. We probably need to look at the frequency above certain thresholds, the number of rain days and things like that. And I think that might also point us in the right direction. Matthew, do you want to add to that? I see you got your hand up.
Yeah, thanks for the good talk. Also, just not only that, the erratic variability in the rainfall, It's interesting that you've seen a decline, and it's potentially that we're receiving less rainfall, but then when we do receive rainfall, it's a lot more intense. So I was just wondering also if your model's actually accounting for excessive dry periods, so not just the high flow events that we're concerned about because of the destruction, but also actually these extreme drought conditions that we could potentially be seeing as well.
Yeah, I don't know if, but just to add on that, we're hoping that when we start looking at our results above a particular threshold, we chose this approach initially because that's what we use mostly in the country. We use annual maximum series, but the next phase would be looking at values above a particular threshold. Let's say, let me use rainfall. Let's say above 50 millimeters. How frequent are we getting that? So hopefully the study will be able to give us responses also when it comes to just how rapid above a particular threshold. But not only that, we're also considering the issue of duration. I think I can throw it there that the only challenge we have is getting data to that level of scale that we need to give the responses that we would love to give ideally. Thank you.
Thank you very much, Damien. Sorry, Lakesh, one last question.
Okay, no, thanks. Now I just wanted to know, with your data, do you look at the zeros, the impact of the zero inflation in your data, or is that in terms of the rainfall? Because sometimes that could skew it. I know when we had some water quality data for our plants, we have a lot of zeros, like zero equal. So we did some statistical projects quite a while back with UKZN where we were looking at some zero inflated time series models and stuff. So I just want to know, in terms of the rainfall, do you sort of account for when there's all those zeros and how that's impacting on these trends? Thanks.
So by zeros, you implying where there's like, we don't get a value.
Yes.
So yeah, that's what we used in the selection criteria. So ideally, what we end up analyzing is record with less values such as that. So we spend a lot of time screening the data. So we chuck away that most data which have got null records longer than a period of 3 months. Yes.
If I could just add to that, so what we're analyzing here is the annual maximum series. So obviously no zeros, no zeros in flow as well as rainfall for that. But I think the impact of the change in the distribution of daily flows or annual rainfall is something that we need to look at in more detail. Thanks. Okay, thank you very much, Damien. Well done. I think our next presentation is due by Sam. Sam, are you online? I don't see you. Can you just identify yourself if you're online? Sam Getoon. Nope. Okay, I don't see anybody. I don't see Sam. So somehow he might be having connectivity problems. I know he is traveling and he was hoping to connect. So maybe we should then just move on to the next presentation. And if Sam, if anybody sees Sam online, please let me know. We can then pull him into the schedule if he does manage to join us. If not, we'll then move on to Nestle as the next presentation.
Greetings, everyone. My name is Minentle Goge, and today I'm going to be presenting a progress regarding my master's project titled Identifying Potentially Significant Sediment Contributing Areas and Assessment of Interventions to Limit Sediment Yield Flowing into the Proposed Smithfield Dam on the Umgeni River. On my presentation, I will cover the background of my study, aims and objectives, methodology, and the challenges I'm currently facing. We all know that water is an important resource to maintain an adequate food supply and a productive environment for all living organisms. Now, Umgeni water is the largest supply of water in the KZN province, and the population of KZN between the year 1996 to 2015 increased by 27%. Now, water resources of Umgeni River system is insufficient to meet the long-term water demand. As a solution, the Smithfield Dam has been proposed as a solution to meet the long-term water demand of Umgeni River catchments. Now, globally, the annual storage loss rate is between 0.5 and 1%. Now, with that said, we can all tell that this is a global challenge. The proposed Smithfield Dam is at risk of reduced water quality due to sedimentation, and about 60% loss of dam storage capacity is predicted in 100 years. Now, as a solution to this challenge, management plans to limit soil erosion and sediment yield are recommended to be developed for the Umkomazi catchments. On screen right now, we just have a catchment overview of the Umkomazi catchments. Now, the aim of my study is to identify and prioritize catchments that are more at risk to be affected by soil erosion and sediment yield, and to assess the impacts of interventions to limit soil erosion and sediment yield in the Umkomazi catchments. The objectives of my study, firstly, is to review possible measures to limit soil erosion. A study was conducted by Umgeni in collaboration with NRR, and they've identified some potential interventions to be implemented. Also, on my study, I have reviewed possible measures, and another objective is to review and select a suitable model to assess the impacts of the measures on erosion and sediment yield. The next step is to configure the model to simulate sediment yield for the selected scenarios. Also is to identify areas that are more vulnerable to soil erosion and to assess the impacts of the selected intervention in vulnerable catchments. And lastly is to evaluate the performance of the model using available erosion data for the catchments. Here on screen right now, I'll just show pictures of some of the intervention scenarios that are to be implemented or to be assessed or to assess their effectiveness. We have agronomic measures. These are your natural-based interventions used to limit erosion. We also have mechanical and engineered structures that are used to stabilize real and gully erosion. These are also pictures of some of the interventions that will be assessed. And here, these interventions has been already installed on some of the areas on the Umkomazi catchments, and they are successfully trapping sediments. For my study, I conducted a literature review to just see models that I can use to conduct my study. And here are just some of the models that I reviewed. And also I selected the best model to conduct my study based on these criteria, which are data required, ability to simulate sediment yield and soil erosion, availability in South Africa, the catchment scale, and also the support that I'll get when I use the model. The best model to conduct this study based on the criteria mentioned was the ACRU model, due to the existing data and configuration for my study area, as well as the expertise available to use the model. The ACRU model is a physical-based model, conceptual daily time step model. It uses muscle equations to calculate sediment yield. The ACRU model has been used, and there's 2 studies to predict or calculate sediment yield, and the model produces good results. These are just some of the results from the study that was conducted by Daniel using ACRU model. Now it shows that the model predicts accurate results, and those results gives me confidence that I'll also be getting accurate results when I'm conducting my study. The model also uses muscle equation, as I've mentioned, and this is the equation that I'll be using to calculate, or the model will be using to calculate sediment yield. Here on screen right now, I have the methodology for my study. I started with conducting a literature review while visiting the site and collecting data, also learning ArcGIS and improving my ArcGIS skills. I'm currently configuring the ArcGIS model for the Umgeni catchment. When I'm done configuring the model, I will do a vulnerability study to identify catchments that are producing more sediments. Then I'll move on to simulating the intervention scenarios. After that, I'll analyze my results, looking at verifying the model simulations and assessing the effectiveness of the interventions. After that, I'll move on to propose the most effective intervention scenarios for the catchment, looking at the scale of the interventions required for the intervention to be effective, as well as the effectiveness of the intervention during extreme events. The challenges that I am currently facing are obtaining data to compare with the model simulation to see if the model is simulating correct or accurate results, as well as obtaining climate data for all the quaternary catchments. At the moment, I only have data for 5 stations from source. Another challenge is to model the catchment into a suitable scale that will give me accurate results for the catchment. The first option will be just to model the Umgeni catchment into 6 HRUs. However, the problem or my concern with that is that we might have inaccurate results. And the second option is to model the catchment into finer scales, have more than 6 HRUs. Now, the question is that really practical? Another option I have is to maybe just model the whole catchment of Umgeni and then maybe model just one quaternary catchment into a finer scale just to get a more accurate result. I would like to thank Umgeni Water for funding me and Prof. Smithers and Prof. Schulz, Dr. Clark and Mr. Horan for their great supervision, family and friends for their support. Thank you.
Thank you very much, Maneshle. So this is obviously an ongoing study. I think a very important study. I think there is concern about some of the interventions that are taking place. Well, there's concern about erosion within the catchment and the impact on the dam, as well as the effectiveness of the interventions that are taking place and the scale that they need to be implemented at to be effective, if that makes sense. Any questions from the audience or from online? Thank you. To the mic.
Thanks. I'm not sure if my question can relate to your study. As Umgeni, we have a big challenge with illegal mining or sand mining. Can this model or this intervention can be applied in those particular areas that are identified for illegal sand mining? Thank you.
We don't want to answer the question. You want to answer? What would you think? So you do think your model configuration could address the impact of sand mining within the catchment? I'm not sure if it's happening in that portion of the Umgeni. I suspect it's more downstream if anybody can correct me, but that's a valid question. Yeah.
At the moment, I am not sure, to be honest. But I think it will, if we were to find out with sand mining how much sediments are being directed to the dam, maybe we just can have an idea. But at the moment, we don't know how much impact or how much sediments are being produced when they are doing the illegal mining.
Thanks. I think it's a very valid question. We've been asked this before, and I suspect we probably need to go more detailed, smaller scale modeling than what we're doing in this study, would be my initial response to that. But I see Kevin has got his hand up. Kevin, do you want to add to that, or do you want to start a new discussion?
No, just to say that that during the feasibility study of the Smithfield Dam, there was quite a lot of work that was done on the dam itself and obviously the catchment. It was recognized that there is a lot of sedimentation in the catchment. The consultants that did this study even looked at trying to create some kind of a sediment barrier at the top of the dam, where there could be pipes that actually travel under the dam or around the dam, so that during flood times, when the sedimentation is so high, that water can be diverted around the dam or under the dam so that that sediment doesn't go into the dam. But it was termed not feasible because of the volume and the size of the piping that would be required and that type of thing. But it is a real problem in the catchment. There's no known sand mining happening in that catchment upstream, and it's the water flows so quickly that it's very, very rocky rather than sandy. The sand does collect further down, and it's just another environmental impact that was recognized, and that the dam would actually hold back some of the sediment, which is, ultimately ends up creating the beaches along the coast. So that's a negative impact on top of the normal sedimentation of the dam, is the lack of sediment coming down the river that's going to add to the beaches. But yeah, it looks like they're going to be very interesting results from your study. Thank you.
Thank you.
Thanks, Kevin. Any other further comments or questions? If not, let's move on. Thanks very much, Mr. Again, just to check, is Sam online? Nope, don't see anybody. Martins, are you online? That's our next presenter, is supposed to be online. Not sure what's happening. Don't see him online. If we can then move on to Nkosinathi. Is Nkosinathi here? There we go. Thank you. Okay. Thanks. Let me just kill this. Nkosinathi, just get your that one, eh?
Yes.
Okay, let's just share this quickly. It's going to and
oh yeah,
okay, that's forward, that's back, and that's a point in the middle if it works. That's forward, yeah, forward to try.
Okay.
Yeah.
Oh yeah. I greet you all. My name is Nkosinathi Emmanuel Madlala, from Chemical Engineering, Howard College, under Reactor Technology Research Group, supervised by Prof. Lockhart. Actually, I'm looking at a sustainable plant-derived coagulant agent in a heterogeneous platform for water treatment. Basically, we are investigating the effectiveness or efficiency of kind of shifting to a bio-based coagulant in terms of removing some solids in the water sampling tanks from the water treatment plant. So we're using diverse plants, but we tend to focus on leguminous plants like soya to extract some protein. So we do like salt extraction. So from salt extraction, and then you injected to silica to improve the surface area and so forth. Basically, the background of the study, there's a long history of indigenous knowledge in terms of bio-based coagulant, especially in Asia, moving towards Europe and Africa, from dated back 17th century. So we've been using this thing while we're drinking water from the streams. We collect water because sometimes we drink with cows. So we collect some water. There's a high turbidity. You come in home, you crush some beans, and then you do some water extraction because you can do water extraction. So you pour, and then you wait a certain period of time, and then you keep the clean water, and then you drink. So that basically. So basically, with the evolution and industrialization, so we tend to focus on synthetic coagulants, where the dominant was aluminium and iron. So we tend to see there's some environmental determinant Afsen, even in Umgeni, they just shifted away from that. They're using polyelectrolytes and stuff. So we tend to, in the study, we are trying to develop a model based. So there are quite a lot of models that have been developed to try and simulate the true simulation and mimicking of the actual environment, what is happening in water bodies, in estuaries, and so forth, in water clarifiers. So in terms of how long does it take after application, applying certain coagulant, how long does it take for individual particles to come together? That's a collision and stuff. And then they form a certain aggregate or a flock, and then they cycle it down at the bottom so that they can be removed. And then the water, they can carry on to another phase of treatment. So basically, we are trying to develop that model. So there are quite a lot of models that have been developed. You know, all of us, we know Stokes law. So Stokes law is not effective since there are a lot of assumption that which doesn't make sense, of which everything is spherical and stuff, but we know it in true nature, something that is fragile. So there are some kind of a lot of shape. If the particles, they can come together, you can develop a lot of shape with pores in that aggregate. So they behave different as Stokes law assumption. So, and also with that, we tend to use there are so a lot of methods that have been used to try and get some data which what is happening inside water column whenever particle or turbidity is involved. So what is happening in terms of particles to come together to be charge neutralized after applying a certain coagulant, and then they cycle now the process. So we tend to use a machine vision system, so some cameras, CCD cameras, to visualize that as it happens, so that we can develop a proper model with what is actually happening in real world. So
Well, okay. All right, thanks. Please carry on.
Okay, sorry about that. Actually, this is a simple reaction of a covalent and a demonstration of what is happening inside once you apply the covalent. And these are the tests below that we've done in the lab to show some coagulation processes that are done using kaolin and so forth. So basically, the aim of the study is to develop a cost-effective organic coagulant agent from a diversified indigenous plant species, mainly glycine, of which is a soybean. So actually, we're comparing this coagulant with the inorganic traditional coagulant. We'll be running a parallel test with the modern used one. So actually we'll simulate and see some factors or indication factors for cost-effective and environmental sustainable coagulant, and try to use that model for the design capacity to meet a certain required design capacitor for the small-scale water treatment plant against average daily inflow capacitor. So basically, the objectives, we have quite a number of objectives, so I'm running out of time, but actually is to characterize natural water particle suspension and develop a literature review for physical equation of cycling solid, those models that have already developed, and see how can we improve, because others, they say they have certain limitations of if certain flocks they go to certain size, they can actually predict, they over predict. If the flocks are very small, they also under predict the cycling velocity. So we are trying to fit that the model that we're gonna develop. So actually, this is a summarized methodology: seed pulverization, sodium chloride extraction, and so forth, until we do the particle image velocimetry and do some post-image analysis for physical characteristics of a flock that are developing inside. So actually, these are the coagulation tests that have been run under these conditions. This is just a simple schematic presentation, and this is a machine vision system. This is the camera and the design box and the electronic components controller with a logic controller, and we will link this thing with MATLAB. So we've run some script code to communicate this controller with MATLAB, so that everything will be done in a MATLAB environment as the model will be developed also. So you're gonna view from MATLAB and transport the data inside the MATLAB and create some database, and also with the development of the model, mathematical model. This is just a simple process or method to develop a model, and this is actually the current model that I'm running with. I'm using this equation from step 5, which because it also includes physical chemical parameters of water, such as viscosity and temperature, and also look at the fractality geometry of the flocks. The flocks that are developing, they are not like rigid in size. They are not spherical. They tend to take different shapes that are not in our vocabulary. So we use parallel and what we call fractal dimension factors, so to develop a model. So basically, we're also able to calculate collision efficiency and the collision frequency inside the water column. So basically, we're gonna the output that we're gonna get, the average cycling velocity and collision efficiency and collision frequency also. And then this is a continuation of the study from MATLAB, and the results I'm having a lot of results, raw data I'm still, because I was struggling with the method of analyzing images from this camera. So there's quite a number of data that I'm busy right now. So I was like having a true representation of the data with how can I represent, because it's quite a number of data. So, but I'll write a report soon and send to Umgeni from what the data that I've discovered. But the model is still running, but it's just that I want to validate it with the actual data that is happening. Thank you, guys.
Thank you very much, Nkosinathi. Apologies for the interruption. I guess that's one of the hazards of living in South Africa, something we need to deal with, unfortunately. I don't know if we have any questions from the floor or any from the online audience. I don't see any questions. Sorry, I can't see. Who is that? First one?
John.
The first one?
Wilson John.
The one to the left. Who?
Monica. Yeah, Monica.
Oh, what's his name? Tabron. Tabron, could you please go ahead?
Yes, thank you, Professor Jeff, and thank you to the speaker. Just one very short question. In the model that you're going to develop, are you going to factor in the raw water stability? Thank you.
Raw water. Oh, sorry. Good question. I think since we're in a laboratory scale right now, we've been using kaolin, but I see kaolin has a homogeneous size. So that's why I'll be visiting a water treatment plant and try to run another test with the extra raw water from the river and see whether this camera also can able to detect the real sizes of the flock that can develop in the real primal particles or organic matter that you will be finding in raw water, so that you can see and compare these two things.
Thanks, Tabron. Does that answer your question? Tabron, sorry, we didn't hear. Does that satisfy your question? Okay, I hope it does. Like we're not hearing you if you're responding, Tabron. Okay, can we then move on to Wilson? Wilson, please go ahead.
I'm looking at a future scenario where this program is rolled out. And I want to know the thoughts of the speaker in as far as agriculture is concerned. We know it's very resource intensive. Do you think there will be a threat to food security should this study be showing advantages of this coagulant in water purification?
Okay, thank you. Yes, since this thing, sorry, the English, sometimes it went. So since it's bio-based, because in some research, if you go through the literature, you can find with him some aluminum and iron or these synthetic that are using that have been used coagulant, they reach the end user from the tap. So sometimes people, they get kidney problems or because of these things, these residues. So if you use bio-based, so especially it's proteinous, so it will be good for them in terms of their healthy. Secondly, in terms of agriculture point of view, yes, there will be a threat in terms of, because now a lot of tons will be diverted to produce this coagulant, but it gives us the mandate that we need to practice a lot of agricultural land, because we have a lot of arable lands that these legumes can be planted. It will also benefit in terms of job opportunity, nitrogen fixation, since the global warming and the climate has become very worse. So if you cultivate a lot of land with these legumes, so we also benefit also in terms of environment and in terms of economy and in terms of jobs, since this country we don't have jobs.
Thanks very much. I think it's a very relevant question, Wilson. Food security is obviously a very big issue that we also need to bear in mind, but it, as you say, does also present other opportunities as well.
Yeah.
Thanks for that. Thank you. Can we please, another question from the floor? I think maybe we would make the last question.
Thank you, Nkosinathi. Have you considered what you would do with the plant material once you're done with it?
Yes, animal feed and some, because once you peel this thing outside its cover, that thing is fiber. So someone, I'm sure, can does something with that fiber. and this green stuff, you can either anaerobic digesters and produce some gas out of it. So it's conservative. It's conservative. Yeah.
Thank you. So the other opportunities, thanks. Very good. Thank you, Nkosinathi. Let's move on to the next presenter. I think we were due for a lunch schedule, but when I went outside, there was a very long queue. So the caterer asked us if we could carry on going for another 15 minutes. And I see Sam is online. So maybe if we can give Sam the opportunity to do your presentation. Sam, we missed out on you earlier on, and you weren't connected, but if you're welcome to go ahead and share your screen and give your presentation. I will be giving you an online warning at about 2 minutes if it looks like you're running over time. So I've got some timers here who are going to prompt me. So over to you, Sam.
All right, thank you, Prof. Can you hear me? Can you hear me, Prof?
We can hear you. We can see your presentation. Thank you. You can go ahead. You're a little bit blurry on your screen. You could turn your video off if that helps in terms of connectivity. Or close your curtain in the background. Looks like audio visual guys say you're a bit light. But I don't think that's going to help that much. But that's fine. We can see your outline. Please go ahead.
All right. Good morning, everyone. Sorry I couldn't be with you in person today due to unfortunate circumstances. Umgeni water postdoc at UKZN. My project is optimization. Sorry.
Sam, sorry, can I interrupt? I think turn your camera off, just might save a bit of bandwidth. We're losing your sound. If you could just turn your camera off. Thanks. Please go ahead. Apologies for the interruption.
I hope it's better now. So as I said, my name is Samuel Gitahun. I'm a Umgeni water postdoc at UKZN Wash R&D Center. My project is optimization of direct potable reuse and rural sanitation strategy and demonstration. For this specific presentation, I would like to focus on the title below, emerging contaminants of concern removal from wastewater solution, a biological treatment, as well as advanced treatment options that we have on the ground at the moment. And if I have time, I would like to, I'll try to update you on the sanitation part of the project. So as you all know, water resources around the world are decreasing steadily due to climatic changes and population growth. And in the case of South Africa, we have water resources have already been depleted or have reached low levels. And it's expected that by 2030, we need additional 17% more water than we have at the moment. So, and to address these shortages, there has been efforts and investigations to find alternative water sources, such as seawater desalination, direct potable reuse, and indirect potable water use. And Umgeni Water has invested for this effort to be realized. And they have addressed and accounted for water programs, water resource management, and one of those is direct water reuse. So water reuse has several benefits. It reduces demands and stress on freshwater supply. It offers a continuous water supply independent of climatic conditions or drought. So it's environmentally friendly and this can be applied for the water connect and indirect potable use. This is the Darwin water recovery plant. As you can see, it has a visitor center where sun and seawater observes. We have multi-barrier technology in place for safe production of water. This direct water reuse plant has conventional treatment and advanced treatment sections. The plant takes around 2 megaliters per day of the final effluent from Darwin wastewater. Plant has rapid gravity filtration sections. The advancement part, which contains ultrafiltration, ozonation, and ground-activated carbon treatment, followed by chlorination. And this advanced treatment process has 2 process trains, as you can see here. And the other, the biological treatment or the nature-based solution I mentioned earlier is called the Daphnia water solution technology. Daphnia is a small crustacea animal that you are commonly found in water bodies, and is commonly used to feed fish. It has a small size, and it has a characteristic of absorbing contaminants, different organic and non-organic contaminants from wastewater streams. So it's basically works as a vacuum, as you can see here in the picture, and the before and after wastewater. So this technology was developed by the University of Birmingham, and the project is a collaboration between Umgeni Water and the University of Birmingham and the Daphnia Waters, led by Prof. Luisa Orsini. So this Daphnia technology has 2 sections, the side stream bioreactor as well as the live environment. The side stream bioreactor is used to propagate and feed the Daphnia, whereas the live stream environment has especially designed cages to keep the Daphnias, and they will be installed in a secondary settler for the treatment to take place. We have recently, it has been a while now, installed propagating these Daphnias in preparation for the field trial. So this technology has been verified at a laboratory scale and has been demonstrated at a field level. And now we are at a commercial testing level where the commercial testing or field trial is going to take place at Darwin. I'd like to share with you the performance of the Daphnia technology as well as the direct potable reuse technology we have in place, and just to see a simplistic overall cost of the 2 technologies. For this, we try to look at different pharmaceutical groups, as you can see here, painkillers, diabetic medicines, and antibiotics, and things like that. So, as easy removal efficiency over, we looked at for retention time less than 4 hours, which is the case for the secondary settler, and obviously the direct potable reuse technology is more efficient. It removes as much as 96-97% of the contaminants of emerging concern, whereas the Daphnia water solution removes from 10 to 60% of this contaminant during that retention time. The Daphne water solution also removes a significant amount of these pharmaceuticals from the wastewater streams. As these tests were conducted in a controlled laboratory environment, just to be clear on that. And when we look at the overall cost of the two technologies, the cost for the Daphne water solution technology doesn't require power or additional chemicals to operate, or the overall operational cost or capital cost of the technology is relatively very low. If we compare this cost and different advantage of the two technologies, and when we say the direct whatever reuse, we have the Daphne seems to have like a value for money, is much cheaper, and when we look at the contaminant removal performance, a wide range of contaminants, and it helps reduce the load on the direct water reuse plant, which is relatively sensitive.
James, it looks like we've lost online. Can anybody hear me online?
We can hear you, Prof, now.
Thanks.
Is it my connection or yours? Where did you lose me?
I'm not sure. Okay. Did we crash here? Sam, do you want to finish off then?
Sure. Where was I? I don't know where you lost me. I was on the conclusion part. Or...
Can we give you one minute just to wrap up? I think you were you had overshot your time.
Right. Let me share my screen.
Can you please just wrap up in 1 minute? Just conclude. Okay. Thanks. So if you can just conclude, please, Sam.
All right, Prof. I hope you heard most of it. So these two technologies, the Daphnia water solution and the direct potable reuse plants technologies seems to be complementary. Having the Daphnia water solution technology in the upstream improves the removal performance of the unit operations. The direct potable reuse plant and the field technology field trials and evaluation and optimization of the two processes individually and combined will take place starting this year. I don't know if I have a minute. I would like to update you on the sanitation wing of my project.
I think we've run out of time. Sam, could you please just stop your presentation? All right. Stop sharing, just so we get a bit more bandwidth.
Sure.
Is there any quick question for Sam while he's online at the moment? Wilson, I see you've got a question. Can you please go ahead?
Just a quick one for Sam, is that the removal is fine for the Daphnia water solution. What I'm interested in is the study or any previous studies show what the metabolites are following the removal by Daphnia? Thanks.
Daphnia technology removes these contaminants by accumulating or breaking down this compounded into simpler compounds. This contaminant, like the body has two parts, the cheating part and the organic part. The organic part sucks this pharmaceutical, the cheating part removes these heavy metals in the wastewater stream. And at the end, we have two options. One is to the amount of the Daphnia residue at the end, like for our wastewater treatment plant, for example, is around, I think, less than 50 tons per year. So it's relatively very small. And we have a research already in place as well to utilize the residues to produce different agricultural inputs and biochars. I hope that answers your questions, Dr. Wilson.
Thanks, Wilson. Does that satisfy your question?
It's fine for now, Jeff. I'll take it offline.
Thanks very much. All right, I think let's go on with our next presentation. I don't see Martin's online. If you are, just raise your hand, but I don't see him. If we can go ahead with the presentation by Rhoda. Rhoda, can you hear us?
Yes, Prof, I can hear you. Can you hear me too?
We can hear you. Can you please go ahead with your presentation? Can you share your presentation?
Right.
I will also try and give you a 2-minute warning when we're coming to 8 minutes or so in your presentation. So please go ahead.
Okay. All right, please, can you see my screen, my slides?
We can see you. Thank you. Please go ahead.
Okay. Good morning, everyone. I'm Rhoda Adegoke. I'm a PhD candidate. I'm in my second year. So I want to talk on preparation and characterization of bauxite graphene oxide and bauxite graphene oxide composite as part of my PhD work. I'm being supervised by Professor Biche Machinchin and Professor Vincent Yamore. Yeah, we are all familiar with water and some of its uses. And you all will agree with me when I say water is a necessity of life. But unfortunately, water sources are being polluted by harmful substances. One of the main classes of contaminants revealed by researchers to have been causing water pollution is the emerging contaminant. And these emerging contaminants are substances that are not commonly monitored, but have adverse effects on human health. This issue of water pollution by emerging contaminants is becoming a matter of global concern. Therefore, there's a need for sustainable solution to guard our water sources and eliminate these emerging contaminants. Though wastewater treatment plants have been using conventional methods for the removal of these emerging contaminants, and the methods they have been using include percolation, ultrasonic treatments, reverse osmosis, and voucher process, to mention a few. But this method that they have been using are complex, and also the material used are quite expensive. But there is the use of absorption over a simplest approach, with which are economical use of economical material for the removal of emerging contaminants in water. This is part of the reason of absorption be an acceptable method universally. So to further improve the absorption method, the absorption can be mixed with a modified material to form a composite, so as to enhance the absorption capacity of the material and to improve the performance. So also quickly, let me go to my material of interest, which are bauxite and graphene oxide. Bauxite is a carbon-stable material that can be obtained through heating of biomass, either thermally or hydrothermally, in the presence of little or no oxygen. It is known for its unique characteristics, which include a large number of active suction sites. They are environmentally friendly, they are of low cost, and they are renewable. On the other hand, graphene oxide is a single monomolecular layer of graphene with various oxygen-containing functionalities such as epoxide, carbonyl, carboxyl, hydroxyl. And also graphene oxide is known for its high absorption capacity, also excellent thermal property, and also have high negative charge density. So this leads me to the aim and objectives of this work. The aim is to prepare and characterize bauxite graphene oxide composites for the removal of emerging contaminants. And my objectives are to prepare and characterize bauxite sample, to synthesize and characterize graphene oxide, to prepare and characterize bauxite graphene oxide composites, and to utilize the composites in absorption study for the removal of emerging contaminants. So here is the experimental part of my work. I would like to start with the preparation of my bauxite sample. Two different biomass material were used, and these are pine pellets and exotic plants, and I denote it in this work as BCH1 and BCH2 respectively. The sample were then pyrolyzed, grind, and bombing into fine powder. On the other hand, graphene oxide was synthesized by improved Omas method using the ratio of 9:1 of sulfuric acid and orthophosphoric acid with potassium permanganate as an oxidizing agent, which was added slowly at low temperature. It was also stirred for 5 hours. Then water was added with hydrogen peroxide to stop the reaction. Thereafter, 5% hydrochloric acid was later used to wash the resulting solution so as to remove the sulfate that might have attached to the surface of the material. Then I washed it with deionized water and put the washed solution in the dialysis tube and continued washing until the neutral pH was recorded. So this slide shows the preparation of bauxite and graphene oxide composite. which achieved by mechanomixing. The different composition of the composites were prepared by varying the amount of biochar while the amount of graphene oxide remained constant. I have some results of characterizations that I've done here, and this shows the Raman spectroscopy. The figure here, figure 4, shows the Raman spectra of the biochar samples, graphene oxide, and these composites. From these results, the purity and the crystallinity arrangements of the sample can be evaluated based on the ratio of intensity of D and G band. The D band for both biochar sample and graphene oxide and their composites were found in the range of 1341 to 1367, while the G band for both this biochar sample and graphene oxide and their composites were found around 1592 to 1596. And the crystallinity and purity of the material is inversely proportional to the ratio of intensity and intensity of D and G band. So therefore, it can be can be drawn out here that the intensity of D band and shows that the two biochar sample and the composites have more disordered carbon side than the graphene oxide. Hence, the composites was successfully formed. Figure 5 shows the powder X-ray diffractogram of biochar from pine pellet, biochar from exotic plants, and also graphene oxide and also their composites. Yes, we can see a sharp peak at 2 theta of 26.6 is common to both biochar samples. And also for graphene oxide, there is a characteristic peaks that is observed at the 2 theta of 12.1. And this peak is known as a distinct peak for graphene oxide, while the peaks that appear at 42.7 on the graphene oxide can be as a result of incomplete oxidation in the preparation of graphene oxide. So for the composites, the characterization peaks of biochar and graphene oxide are present, which suggests the successful formation of the composite. The thermal analysis for the samples were done. The thermogram of graphene oxide in figure 6 shows a weight loss at 200 degrees centigrade for graphene oxide, which is due to removal of oxygen or loss of water that might be present. And the final composition of graphene oxide is at 501 degrees centigrade as shown in table 3. And also an initial weight loss in all the composites from the room temperature is around from room temperature to 120, indicate the evaporation of absorbed water on the sample. And also a remarkable weight loss was also observed at 200 to 400 degrees centigrade, which is due to the composition of oxygen functional group. The decomposition temperature shown in table 3A and 3B reveals that all the composites are thermally stable at high temperature.
You got 2 minutes left, Rhoda.
All right, I'll be rounding up now. The pH value of biochar graphene oxide composite and graphene oxide were evaluated, and the table 4 indicates the pH when the net charge on the surface of the material is neutral. This is called the pH PZC value, and this is important to understand the interaction of the surface of the charged material due to the electrostatic effect. The scanning electron microscopy was utilized to ascertain the morphology for both biochar sample and also their composites. The images shows a smooth for both biochar sample, the raw, shows a smooth surface on the sheet at different sizes, but the pores are not obvious. This implies that the formation of composites with other material will be necessary to modify the biochar sample. In conclusion, the intensity of D and G band shows that Boucher samples and Boucher graphene oxide composites are have more disorder composites than graphene oxide. And also the thermogram and derivative thermogram for Boucher and Boucher graphene oxide composites shows a higher degradation temperature than graphene oxide, indicating that the composites are more thermally stable than graphene oxide. Also, Boucher graphene oxide, Boucher sample graphene oxide and their composites were successfully prepared and characterized. These are my future work. The batch absorption study on the selected emerging contaminants will be done by using various parameters, which include concentration, time, and temperature. And also, I will feed the absorption data to various kinetic and acetylene models to study the underlying absorption process. And I will determine the thermodynamic study parameters of the absorption. And also, I will investigate the desorption process and recycling of the adsorbent, and to prepare the material developed to real water sample. Finally, I would like to appreciate Umgeni Water for their funding, my supervisors, the WRC, Rewa, and the Almighty God. Thank you all for listening.
Thank you very much, Rhoda. Yeah, that's great. Thank you. I'd like to open the floor to any comments or questions. Mr. Adu, Peter, could you please go ahead? Adu, Peter, I'm not sure who that is. Could you please go ahead? You had your hand up. Oh, Cappy. Sorry. Okay. I don't see any questions. Thanks very much for that, Rhoda. I think we overdue our lunch break. Let's break. I think we've got 40 minutes. So can we try and have lunch by 1:30? I know we are quite a way behind schedule. And I guess our next speaker will be in Kita after lunch, if that's okay. Everybody happy? We'll try and commence proceedings again at 1:30. So it gives us a 35-minute lunch break. Thank you very much. Thanks for your attendance, and we hope to see you, those of you online as well as in the room, at 1:30. Thank you. I believe lunches around the corner to the right. I think we will be locking the venue as we go out to lunch. Just if you want to leave anything here, it should be fine. We will lock the doors. No, but this is the equation for the parameters which influence the so I don't know how to do it. You guys just say I ran chain using
That's very sure. The low also. I have some changes. I can tell you when we do a stationary analysis of the yeah. Oh, because I'm trying to see how we could do it. There's no way because for one can we link the flow to a depth? Yeah, we're gonna link the depth. Yeah, but passing a particular, there could be more things passing, but passing a passing. So for instance, is it showcased that 15 millimeters generates, let's say 100 meter cube per second? Is this guaranteed? Yes, you see, because then what I'm saying is you could have more frequent rainfall, but which does not translate to a peak, a noticeable peak. Other areas where they have this reported like I mean, what we do here, even if you can find one, this gives us because now I can tell you how frequent you get arranged this way. So can we look at we're going to be transferring footage to edited, yeah. You can get a copy of wow. That's waiting. No, so what we do is because the university, our normal rate is this, but we have a university. Oh, Jesus. Yeah. It just takes us a bit long. That's fine. There won't be something here. We don't have to. No, you can go because once you start, then it's when you can see how many minutes and you go and you stop going. Sure, you go. They did say they come and change water and yeah. No idea. That's I think that's one of the things. I don't know if it's a cable or it's nothing. It's just like for the same. Oh yeah. Maybe my how was that? You don't know this. That's it. And it's good.
Scott, I'm going to get pocket back picture that you can go to the line.
Oh, I was almost like, hey, it's over. Who's on the line for the lunch? Oh, yeah. If I have an option, I always choose outside. Hey, inside good for Lapo I have my introverted days.
Wow.
I'm an ambivert. What the not chapo vale la kono stop.
No, but sounds okay. But it was okay. You know. Oh, so yes.
What? I think I am that you want bola.
Since you know, what's better?
Oh, oh, now.
Wow. The line, they got what, 5 guys then. Where's the right? This year, it's not passage. Oh, okay. Consider.
It's not outside. They don't sort like it. They was sorted. Such as near the school when they're they got
right there by the spoons.
So when you buy things up. Put it in. You just put it straight into the spot. Those 4 guys you see together was when I started.
Yeah.
But for about 3-4 years now.
Jack, I had more screen, not a screen, not a projector. Made it look more good now. Everything running smooth. Cooks in the 1 point. They got me great. Thank you. Thanks. I can believe that the roast time is slow.
What are the dog?
Viren. Viren, can you mute your mic, please? We can hear your dogs barking.
You know, you have got the headphone mic kind of thing, so you can't hear.
After that job we did there in Westport, the job comes up. It's the latest event, they forgot about Roche. No. After that day, never. Okay, right? Finish off the lab. I think completely just sound everything. We wouldn't know everything. Stop for a video. You can't run the big lights, you run maybe LEDs. Maybe some LED lights. This before. The school had 8 speakers.
Yeah.
Full band. Lighting, big bar, lighting. Projectors, and cameras, the screen, something like this, yeah. Right. So that this plus all of that, right?
Yeah.
The 4 together.
Certificate. CRTI. 30 to 50. Huh? Thanks.
Huh?
Certificate. Correct.
What?
Correct.
CR.
CR, yeah.
TIF.
Yeah.
BI. CHE.
Huh?
CDR TIFI CHE. Certificate.
TI.
FI.
FICATE. Yeah, health and safety certificate.
Hey, how's Sean?
Doing well.
Oh, the thing, there's a whole lot of flooding and all that.
No.
New Zealand? Huh? Safe. I'm gonna check my nephew license. New Zealand. As I'm there, tricks. Tricks. Hectic.
I took you on that, man.
I mean, fine.
Then COVID. Like it had COVID.
Oh.
Yeah.
One was it. All the dogs, finding all the bodies, finding all their life. Like I won't take the dogs to the supermarket. Nobody take the I don't want them, when they're shopping, they're just, yeah. You don't want two dogs fight, what are you going to do? You don't want the investment. You don't want like.
You'll be surprised that amount of money that people spend on it.
My friend, he's got his dogs up some anxiety, right? So you can't leave the dog at home.
Right.
And when you go shopping, you can't even the shop. So if he's at home, if escape goes next door, there's two massive dogs with each other. He's in the house, I think, or flat, and then the neighbors getting out. So you take the put in his car. He won't take it.
No.
So I gave him an idea. Simple. I don't know. Put on the window. People understand. He said 3 oaks already came up to him and said they were laughing. They said, yeah, we understand this. Comes two girls in this thing.
So fucking proper hotel for dogs only. You know that? What? I'll get you the details. If you're going anywhere, you leave a dog in the hotel.
I just told my idea. No. You know what I wanted to do? You know that people are complaining about Diwali and all of that.
Yeah.
I said, guys, so I said, in the rural areas, let's people stop killing. Let's see if we go. $100 a night or something. You can manage.
Do this, Mike, all of that.
It's on. That's the one you sent to Susan. This was now and keep it 12. So what? See who's online. Is there anybody here? Yeah, who was that? I think so. Quite a few coming up. No, Prof, you haven't missed anyone. Yeah, I'm just looking at one's coming up. I don't see them online. Akil. Umgeni. Let's go, T. Let me introduce you and just check please.
Okay, good afternoon, everybody. Can you confirm that you can hear us? Whoops, apologies for that. Anybody online, can you confirm that you can hear us?
Yes, Prof, we can hear you.
Thanks, Zama. Right, we're going to go to our next speaker, who's Nikita. Let me just get her presentation up and share it. Okay, I've got to do that, and I've got to do that. Right, Nikita, the floor is yours.
Thank you, Prof. Good afternoon, everyone. My name is Nikita, and today I will be presenting the results from my master's project titled Analysis of Targeted Pharmaceuticals and Metabolites at a Wastewater Treatment Plant in KwaZulu-Natal. Pharmaceuticals play an integral role in everyday life for many South Africans, with the South African pharmaceutical sector being the largest in Africa. In recent times, there has been concerns towards the occurrence of emerging contaminants. These are chemical compounds that have harmful effects on aquatic ecosystems. Pharmaceuticals are not completely metabolized by the human body and enter sewage either unchanged or as metabolites, some of which still have potent psychoactive abilities on aquatic organisms. This study aimed to identify and quantify selected pharmaceuticals and metabolites present at a wastewater treatment plant in KwaZulu-Natal. The aims were achieved through the development and validation of methods for extraction, cleanup, qualitative and quantitative analysis of compounds, analyzing for these compounds using liquid chromatography, mass spectrometry, determining seasonal trends and removal efficiencies of analytes, and undertaking an environmental risk assessment. Figure 1 illustrates a chromatogram that shows analyte separation taken at 233 nanometers. Table 1 outlines the instrument parameters that were used to obtain this chromatogram. The first peak we have is metformin, which is commonly used for the treatment of diabetes. This is followed by caffeine, which is a commonly used stimulant and is also used as a pollution marker in these studies. This is followed by hydroxylamine sulfamethoxazole and sulfamethoxazole, which are metabolites and parent compound respectively. Sulfamethoxazole is a commonly prescribed antibiotic. The next peak is primidone, which was used as an internal standard. This is followed by nevirapine, which is a first-line treatment for HIV/AIDS. We have prednisolone as the next peak, which is the metabolite of prednisone, which is commonly used to treat inflammation and respiratory illnesses. The next peak is valsartan, which is used in antihypertensive treatment. And this is followed by rifampicin, which is used for the treatment of tuberculosis. 17-alpha ethinyl or EE2, is commonly found in female contraceptive medication. The final peak is ivermectin, which was infamously used as a treatment for COVID-19 during the pandemic. The first set of data looks at pharmaceutical analysis at a wastewater treatment plant during COVID-19 infection waves in South Africa. This is divided into 3 categories. Firstly, we'll be looking at pharmaceuticals prescribed for chronic illnesses. These include metformin, nevirapine, valsartan, and rifampicin. The x-axis represents days of the week, and the y-axis represents concentration in milligrams per liter. Samples were taken once daily for 7 consecutive days over 3 sampling periods, being February, April, and June 2022. Overall, trends that were observed with this class showed that there was somewhat consistent daily usage between the seasons, which is expected with this class as they are used to treat chronic illnesses. Overall, with the exception of rifampicin, we see that April had the lowest concentrations compared to Feb and June. This could be attributed to the April 22 flooding event that occurred within the province. A higher than usual influx of stormwater would have thus diluted the wastewater stream. The metformin outlier could be attributed to 2 factors. Firstly, improper usage or improper disposal of the pharmaceutical. As metformin is excreted largely unchanged from the human body, it would therefore be difficult to determine the exact cause for this outlier. With rifampicin, however, we see higher than usual concentrations in April. This could be attributed to incorrect disposal of unused or expired medication on a relatively large scale, as rifampicin is majorly metabolized by the human body, so a relatively small percent is excreted as the parent compound. The next class looks at stimulants and self-prescribed pharmaceuticals. So these include caffeine and EE2. With caffeine, we see that June had the highest concentrations throughout, and this can be explained by June being the start of the winter season in South Africa. So more people would indulge in high caffeine content beverages such as teas and coffees during this time. With EE2, again, we see that June had the highest concentrations, and this could be explained by referring to a study done by Stats SA in 2017. So from their study, they found that most babies were actually conceived in June from that year. This would mean that there is an increase in sexual activity during this time, which would directly relate to an increase in the use of contraceptive medication. The third category looks at pharmaceuticals used for the treatment of COVID-19 and influenza. Figure 4 is a graphical representation of the total active COVID-19 cases experienced in South Africa. And drawing your attention, the first asterisk represents the Feb sampling season, which had the highest number of active COVID-19 cases. We then have the April sampling season, which had the lowest number of COVID-19 cases, followed by the June sampling season, which had an intermediate number of active COVID-19 cases. Looking at the data with sulfamethoxazole hydroxylamine and sulfamethoxazole, we see comparable, if not higher concentrations found in June, and this could be due to June being the start of the influenza season in South Africa. So more sulfamethoxazole containing antibiotics would have been prescribed during this time. Prednisolone and ivermectin followed the trends shown on figure 4, highest concentrations in April, correlating to the highest number of COVID-19 cases. Feb, the lowest in April and an intermediate in June. With the exception of the prednisolone outlier, this would exclusively be due to improper usage, as prednisone, which is the parent, has to undergo complete hepatic metabolism in order to become prednisolone, which was detected. A major decrease observed in the use of ivermectin for the month of June could be explained by more people being vaccinated against COVID-19 at this point in time, and additionally, SAPRA banning the use of ivermectin as a treatment for COVID-19 in May 2022. The next set of data looks at removal efficiencies and an environmental risk assessment. Figure 5 is a graphical representation of analyte concentrations from each sampling point. The x-axis represents the sampling points, which include the inlet, the balancing tank, the secondary effluents, and the maturation river. Again, the y-axis shows concentration in milligrams per liter. As we move from the inlet to the maturation river, we do observe a decrease in concentration, which is expected. However, the most noticeable decrease is observed between the secondary effluent and the maturation river. A possible explanation for this could be photodegradation of the compounds occurring as the maturation river flows for a few kilometers and is exposed to the elements of nature as it descends into the receiving river. Table 2 shows the weekly average removal efficiencies of the compounds over the 3 sampling periods. Figures highlighted in red indicate removals less than 50%. Overall, the removals were acceptable. However, there is no consistency observed between analyte removal on consecutive days and also between seasons. This is simply because there are so many different factors that affect removal efficiencies, such as sludge retention time, pH, biomass concentration, temperature, rainfall, just to name a few. And for this reason, there's no consistency between a specific plant and also between 2 different plants. An environmental risk assessment evaluates the likelihood of a compound to exhibit adverse effects on living organisms. It is calculated through equation 1. MEC refers to the measured environmental concentration, which is taken from the study. PNEC is the predicted no effect concentration, which is the maximum concentration that will exhibit no adverse effects on a living organism. And this is taken from literature. A risk quotient greater than 1 indicates that the compound is of environmental concern. From the data in table 3, we see that metformin and valsartan were the only 2 compounds with risk quotients less than 1, indicating that they are not of environmental concern. Most alarmingly are the RQs for EE2 and ivermectin, which are substantially high. This is of grave concern as EE2 has the potential to cause the feminization of male organisms and infertility amongst female organisms. These characteristics could cause the extinction of various species over time. Additionally, ivermectin has the potential to adversely affect basic motor functioning, reproduction, and growth in various living organisms. To conclude, seasonal trends were observed that correlated with COVID-19 and influenza infections in South Africa. Removal efficiencies were acceptable with a few exceptions, such as caffeine, sulfamethoxazole hydroxylamine, and sulfamethoxazole. And the environmental risk assessment studies showed that E2 and ivermectin pose a great risk to the environment with their risk quotients greater than 1. These results basically emphasize how desperately we need guidelines and legislation indicating maximum allowed concentrations of these pharmaceuticals in wastewater effluent. I would like to acknowledge my supervisor, Professor Brenda Mudley, Umgeni Water for their financial assistance, Megan Tabang and their respective teams for their kind assistance during my sampling trips, UKZN's School of Chemistry and Physics technical staff, and the Analytical Environmental Research Group. Thank you.
Thank you, Nikita, for that clear and concise presentation. I'm sure there are going to be some comments and questions from the floor. Any comments or questions, or from the audience online? Damien, if we get a mic here, please.
Thank you. It's Damien Mokansi once again. I just wanted to ask, when you say feminization of male organs, is that inclusive of humans, or it's just
okay, so thank you for your question. Basically, this would majorly affect the aquatic life in the receiving river first. You would then get adsorption into sediment and soil within the river. So by the time the water reaches us in our taps, the concentrations wouldn't be as high, but it still is of concern. I don't think it would affect humans based on our body mass and the concentrations being in milligrams per liter. A bit worried.
He's looking much relieved at that response. Matthew?
Yeah, no, thanks very much for the study. It's very much needed. You mentioned the environmental kind of impacts on fish and that type of thing, and we're already seeing kind of detrimental results with the work we're doing, which is more population survivability of just the high concentrations of stuff that's moving in. So obviously the fish would need to persist in the environment to kind of be exposed to that level of transformation. But is anyone looking at that type of work?
Not that I know of, but it is definitely an interesting topic to research further.
No, I think because I know one could look at it using zebrafish facilities, which the UKZN is now starting to start up, and then you can look at concentrations through that. But what I'm very interested in is actually using local species to see what the impact is on particularly fish species that are targeted by fishers.
Mm-hmm.
So Clarius charipinus, the barbel, the tilapia, and even the yellowfish. So it'll be interesting to know what concentrations persist in those organisms that then relate to food on the table. So it's not just the water we drink, but also what's the trophic level persistence in those compounds. So yeah, thank you. Very good.
Thank you.
Thank you. It looks like Matthew should be having discussions with this group and with Brenda as well. Thank you for that. I don't see any other. There's a Wilson, please go ahead.
Many reports suggest that especially as pharmaceuticals pass through the wastewater treatment works without being removed or with a very low removal efficiency. Can the speaker comment on studies that have been done previously where such a claim has been made, and how does it compare with your findings? Thanks.
Okay, thank you for the question. I just want to confirm that I understand it. Basically, how do my removal efficiencies compare with those done previously in other studies?
Yes.
Okay, so from looking at literature and other studies, my removal efficiencies were comparable. It's just that there's a lot of variance as there's so many different factors. The flow rates differed majorly on a day-to-day basis, and it would be difficult for prior studies done at other treatment plants to have very similar removals based on the pharmaceutical range that I selected. I don't know if that answers your question for you.
I think we'll have further discussions offline, but thanks for answering. Thank you.
Thank you.
Thank you. I don't see any other hands here or online, so thanks very much, Nikita.
Thanks.
Thank you. I still don't see Martin's online. If Martin's if you can identify yourself, if you're online, but I don't see you. Let's then move on to our next presentation, which is by Relebongile. Relebongile, can you hear us?
Hi, everyone. Yes, I can. Can you hear me?
Yes, please go ahead. You're welcome to share your slideshow, and the floor is yours.
All right. I'm having a bit of issues with my PC, but I'll try.
I think we've got your slideshow.
Yes, that
if you
would
need
be
us to show it.
I think that's better.
Would you like us to share it this end, and you can just tell us when to change
Yes,
the
thank
screen?
you. Thank you.
Okay, let me just do that quickly. Let's close this one. Right, can you see the first slide?
Yes, thank you very much. Hi,
just check.
everyone.
Yeah, great. Just tell me whenever you want to turn, I'll do the clicking for you.
No problem. Thank you. Hi, everyone. So my name is Relebohile Morake, and my study focuses on the evaluation of biochar and activated carbon produced from different feedstock for removal of pharmaceutical compounds found in wastewater. We mainly focusing on DWAT systems. Next slide, please. Next slide. So urbanization has led to many global challenges. More so is the increase in the rate of production of pharmaceuticals to cater to the never-ending demand. Pharmaceuticals are designed to interact with living systems by producing a pharmacological response at trace levels, therefore making detection and monitoring very difficult. These pollutants find their way into the environment through various pathways. As seen on the figure, on the left, these compounds make their way mainly through domestic sewages. Patient use is also a principal pathway through which pharmaceuticals enter wastewater treatment plants through excretion from the body. Furthermore, improper disposal of medication is also another way in which these pharmaceuticals make their way into the environment. So the issue that we face is that conventional wastewater treatment plants do not completely remove pharmaceuticals. And there was a study that was conducted in a Durban wastewater treatment plant that found the removal efficiency of acetaminophen was around 60%, which then insinuates that the other 40% of the compound may be released into the Umgeni River. These compounds pose a huge risk to the environment, such as promoting natural resistance to antibiotics, and therefore making these pathogens very hard to treat. So the remedy to this is that sustainable ways have been implemented to remove these compounds, and these sustainable ways have been to remove these compounds have been explored, and biochar and activated carbon are the two materials that have gained popularity in this field of study. Next topic, please. Next slide, please. Raw feedstock is turned into biochar through the process of pyrolysis. Pyrolysis is the process of thermal decomposition at high temperatures, usually in the absence of air. The yield and composition of products are greatly influenced by the operational parameters of this process, such as the temperature as well as the reaction time. So through this process, biofuels or carbonaceous material can be produced and can be used for a variety of applications. Pyrolysis can then be categorized into three main categories, which are slow pyrolysis, intermediate, as well as flash pyrolysis. So for slow pyrolysis, it mainly produces biochar, and it's done in several hours in a temperature range of 300 to 800 degrees Celsius, while intermediate usually is used to produce bio-oil with a reaction time of mainly seconds and a heating range of 400 to 600 degrees Celsius. And then lastly, we look at flash pyrolysis, which is used to produce biogas within seconds, and its temperature ranges from 600 to at least 1,200 degrees Celsius. Next slide, please. To bring in biochar for application, we need to make sure that the porosity and the surface area of the biochar is studied, or else desirable features must be stimulated onto the biochar, and this is done through the process of activation. There are two main types of activation, which are chemical activation as well as physical activation. But for interest of this project, we mainly look at chemical activation. Chemical activation involved addition of activators, which may be alkali metals, chemical acid, as well as bases, to enhance the physiochemical properties of this biochar. We chose chemical activation because it requires lower temperatures to create a more porous material with a high carbon content. This kind of activation also works well for preparing mesoporous structures, which can be useful for absorption of large molecules, as in the case of pharmaceuticals, as well as other pollutants. Next slide, please. So my objective for the study was to produce and generate activated carbon through pyrolysis from three renewable biomass feedstocks, which are namely eucalyptus, black wattle, as well as horse manure. We also try to understand the physiochemical composition of activated carbon and biochar through characterization methods. We test the absorption properties of the biochar and activated carbons produced from the different feedstock through absorption experiments to try and find a material that's best suited for removal. We expect, so the expected outcomes from this study is that we expect to improve the understanding of biochar and activated carbon from different feedstock as a mode of removal of contaminants found in DWAT systems. Next slide, please. So 3 different feedstocks were used for the pyrolysis at 2 distinct temperatures, which are 350 degrees Celsius as well as 700 degrees Celsius. So the pyrolyzed material was further activated by basic activation using potassium hydroxide as well as acid activation using phosphoric acid. The biochar and activated carbon were then characterized by SEM, TM, XRD, BET, boom titration, as well as TGA. So the highlighted characterization methods are the ones that we have done, and the other ones are still in course. And then a 1-point absorption study was set for the biochar and activated carbons. So the conditions that we used were a dye concentration of 200 ppm, and it was done at room temperature, and the pH was at 7 because normal pH of wastewater is around that. Tartazine dye was used as a proxy in these experiments instead of the pharmaceutical compounds, but a further comparison of results will actually be made with actual wastewater samples obtained from the KwaMashu DWAT's treatment plant at a later study. Next slide, please. So pyrolysis temperature is an important parameter in the biochar as it affects the physiochemical properties of the biochar. The figure illustrates the effects of temperature on the 3 different feedstock. As shown in this figure, there was a direct proportionality between the percentage yield and the pyrolysis temperature for all feedstock. So the yield decreased approximately by 30 to 40% as the temperature was increased from 350 degrees Celsius to 700 degrees Celsius. And this can be explained by maybe due to water loss, volatile matter, and decomposition of complex components such as hemicellulose and cellulose, which are mainly found in the 2 wood samples. Next slide, please. So proximate analysis gives us a clear insight on the carbon content, moisture content, as well as volatile matter of the materials. From the table, we can see that pyrolysis had a positive effect on the carbon content as it's seen between the raw materials as well as the biochar. That's the pink and the yellow. Horse manure samples of all the different conditions seem to have the highest ash content, and this is due to the organic matter that is found in horse manure samples compared to, inorganic matter found in manure samples compared to the wood samples. The highest carbon content that was found in the study was 80%, and that was for eucalyptus at 700 that was activated using phosphoric acid. Next slide, please.
Can you start wrapping up? You got under 2 minutes.
Okay, so this is just a basic table of the pH, PZC values. We usually use this to identify whether the surface of the material is acidic or basic. We can carry on to the next slide. So these are my results from the absorption experiments, and from the results obtained, there are 2 noticeable outliers, and we are still trying to maybe repeat those experiments. But not taking account of the outliers, the highest percentage dye removal occurred for eucalyptus that was activated by KOH at 700, which removed approximately 25% of the dye. However, there was no other correlation between the pyrolysis temperature or the 2 activation processes. Next slide, please. So this is a BT analysis tells us about the surface area of the material. And biochars produced at 350 degrees had the lowest surface area compared to all other materials. Activation seemed to drastically improve the surface area of the 350 samples, and KOH activation seems to portray a constant surface area amongst all three feedstock compared to that of the acid activation. Last slide, please. So in conclusion, activated carbon from three feedstocks were prepared, characterized, and investigated by a one-point absorption study. The percentage yield of biochar decreased as the pyrolysis temperature was increased. And the general trend that's observed from proximate analysis is that pyrolysis had a positive effect in the carbon content of the material. No significance was observed between absorption capacity of the activated carbon and those of the non-activated biochar. So from all these findings, we can conclude that there are no correlation between the pH, PZC values, the BET surface area, as well as the carbon content to the absorption capacity of the material. This suggests that there are more complex mechanisms at play in the absorption of dye and therefore may need further investigation. Last slide, please. I would like to thank Umgeni Waters, my supervisors, Dr. S. Stringel, and Dr. Prof. Lockhart, as well as Prof. Matenzi, our collaborators, which are Umia University and Mohammed Fifth University in Morocco. Thank you very much.
Thank you very much, Umgeni, for that presentation. I'd like to open the floor for any questions or comments. I don't see any. Damien in front.
Thank you very much. Once again, it's Damien. I just wanted to ask, from what I think I noticed, I see that there is a higher absorption at 700 degrees Celsius, but yes, there's less yield. So I just wanted to find out if you also get less yields if you have high frequency, less duration, because I'm assuming maybe the duration was the same. So high frequency, less duration, which would probably make more sense in terms of energy in the industry. Thank you.
Sorry, can you please repeat the question?
Okay, so I was just relating the presentation on the slide now, where you can see that you have less yield for 700 degrees Celsius. But when you move forward, when you look at the absorption graphs, the one for 700 degrees Celsius showed a higher absorption. So one thing I just wanted to find out, is it the same for your yield if you did a high duration, short duration, high temperature, which would make sense from an industry perspective?
So we did not look at the reaction times we didn't compare reaction times, we just stuck to one reaction time. So we'd need to maybe look at that to see if that would also influence the absorption of the material.
Thank you. Thank you for that. Any other last question? If not, thank you very much for your presentation. I'm just going to stop sharing and see who's next. Again, just to check, Martin's not online. Don't see that he's joined the meeting. I don't know what's happened to him. Who's next? Akil, are you online? I thought I saw you online earlier. Akil? Yep. Also not online. Okay, I think we'll skip those. If they do join us, we'll slot them in a little bit later, but it looks like we are running out of time to slot them in. Samira Majum will be compiling a video clip, and which that will also be included in the distribution list. So you can view her presentation there. She's unfortunately not available. And that then brings us to our last two speakers, I think, for the day. So Matthew, if you'd like to come forward.
Thank you. Thank you, everyone. My name is Matthew Burnett, and I'm presenting a work that hasn't been presented on before. It's an Umgeni water affiliated project that wrapped up at the beginning of last year. Kind of dedication to the student that we had on the project that passed away during the project. So I'll be presenting some of the work that he did, as well as we did as a team. And the work we were looking at was Spring Grove Dam. Primarily, there were two kind of components to the study. One was to see if the Spring Grove Dam could be a potential commercial fishery. And then also was to look at the efficacy of the fish barrier that was built upstream to prevent the movement of smallmouth bass into the trout fishery upstream. The Spring Grove Dam was built as part of the Umgeni water transfer scheme to provide water into the Umgeni catchment to meet the water demand in Pietermaritzburg and Durban. Spring Grove Dam was built in 2013 to supply water to the two districts. And part of the impact of this was inundated a waterfall called Inchbraki Waterfall. And this allowed movement of fish, and particularly invasive fish, from downstream upstream into the trout waters. And a fish barrier was built to mitigate this, and was to protect the established trout fisheries upstream. This is just context here. So this is the Moy River. This, and on the bottom left-hand corner, is the Inchbraki weir before it was inundated. And it actually stopped the movement of smallmouth bass, which is the top left here, and from entering trout waters, which is the bottom left here. And this is the upstream trout waters and the downstream bass water. Spring Grove Dam was built and filled up, and you can see it inundated the Inchbraki waterfall, and mitigation measures were put in place to stop the movement of bass up into trout waters by establishing the fish barrier. And this is then the fish barrier that's been built, and partially was to evaluate that. Just a bit of a background to fisheries in South Africa is that it's been poorly established in water storage facilities. As an added benefit to having a water storage facility. It's largely been neglected since the late 1980s, early 900s, and that's seen by the failed reporting to the FAO. A few commercial ventures have been pursued, but haven't actually succeeded. I think to date, there's only one successful commercial fisheries, and that's in the Free State. On the other hand, recreational sports fisheries associated with fish, but often invasive and non-native species. But this value can amount to about 23 billion rand per annum. Actually, I can't see the bottom, but just move it up. Yeah. So one component is that small-scale fisheries is notable, but it's also largely neglected. So just the aims of the study was to evaluate the fishery potential in Spring Grove Dam, and then also assess the viability of a commercial fisheries and the target species that would be, and then just to determine the efficacy of Inchbraki fish barrier. Our methods were just using fight nets and gill nets. Basically, we had to go out and catch fish, and also using electroshock in river sites. And then we did calculate a catch per unit effort per gear. And then we also calculated the potential yield for the dam as well. The calculation's just there, so it's not too important, but shows you what we did. Yeah, that's probably better. Yeah. So it's what we did to include in this was we did a presence absence analysis of the data that we collected, and we also scanned databases and social media for records of bass species across KZN, and this fed into a model that we used to determine the potential, or what's the right word to use, to determine the potential invasive locations of smallmouth bass into the upper catchment. So this is just some of the results of the study. This is across the dam where we sampled, and you can see predominantly upstream is still very trout dominant. This is largemouth bass upstream of Inchibraki. The triangle is the barrier. Downstream of Inchibraki, there's a mosaic of different species. What we found in the study was that they're mostly non-native invasive species, with only 3 indigenous fish species caught. But what was important to note was that there was no smallmouth bass found upstream. So this is just the abundances of the species caught. Some examples: this is trout up at Imvamoy. This is in Inchibraki itself. This is rainbow trout, that's brown trout, and then smallmouth bass, largemouth bass, and then bluegill. What was concerning is that what was good is that we found African angulid, Mozambique. What is concerning is that it was probably a remnant population that was there before Springrove Dam was built. These are catadromous migrators and require connectivity to the ocean to spawn and complete their life cycle. And then also was concern was that we didn't detect any of these indigenous species that should, apart from these 2, that should occur in the study area. And Phyllis natalensis has just been listed by the IUCN as a vulnerable species. And Labio rubomaculatus is also a endemic to the Tugela River. So just some of our catch per unit effort results here, basically showing that the CPU was very low. And that's kind of the take-home message there, is that electroshocking was considered the highest CPU, but it isn't possible to use in a fisheries venture. And we use that really primarily to do our fish community assessments. And then the results of the CPU are just detailed there, is that we had the highest catch was largemouth bass and brown trout, which is kind of expected. What was important here is that the yields calculated for Springrove Dam was only about 14 kilograms per hectare per annum, and that calculated to about 14.97 tons per year. Okay, so that's very low yields in comparison to other studies. We're probably looking at needing at least 120 tons per year to have a viable fisheries. The results of the habitat modeling to see what the extent of bass, if the fish barrier wasn't there, or if bass would make their way upstream of the barrier. This is just suitability of habitat for the smallmouth bass, the largemouth bass, and then the spotted bass. And you can see by far the smallmouth bass can be far more widely distributed than the smallmouth bass. And then we also looked particularly at the area above Inchibraki Falls. So what was interesting here, smallmouth bass, most of the area upstream of the bass actually is unsuitable for smallmouth bass. Up to 68% is unsuitable. For spotted bass, it's more suitable. So it's only 45% is not suitable, and 35% for largemouth bass. Largemouth bass, the area was most suited for. And then the highly suitable zones for smallmouth bass was only 8% of that upper catchment, and for spotted bass was only 20%. So this for the species, the highly suitable areas were found in the lower sections of the catchments. Obviously, the upper catchments too cold, species don't occur there. And this translated to 27-kilometer length of the river. This is just the results there again, showing this is smallmouth bass. You can see it kind of stops around there. This is the same map, but this is with largemouth bass, and you can see quite high up into the catchment. Spotted bass, still not upstream of the barrier, but if it were to occur, could occur a lot further upstream. These all relate to risks to the trout industry. Just some conclusions: low yields cannot support a commercial fisheries. Recreational brown trout fisheries, on the other hand, can be.
Might be old, sorry. 12, 13.
Yeah.
Okay, sorry, continue.
Okay, that's fine. Yeah, so it just in terms of funding for that type of stuff, it's more ecological focused. But I think downstream management and flow releases is something that's important to consider if we're looking at environmental flows, particularly since we're moving a whole lot of water from that catchment into the Umgeni catchment. We're augmenting the Umgeni catchment, but actually depleting the Umgeni catchment of water availability for, and just the big thing is the invasive species there that just dominate the system. So yeah, there's definitely scope for work. It's trying to find the funding for that to do the work.
Thank you. So we need to have a good look at operations as well and integrate that into the bigger picture. Any other comments? I don't know, Wilson, if you want to add anything to what Matthew just said.
Nothing for now, Jeff. I lost connectivity for about 4 or 5 minutes, so I missed a bit of the conversation.
That's fine. We'll pick it up outside of this. The continued funding, I guess, from Umgeni Water for the aquatic research. Thanks. Thank you very much for that. Thank you, Matthew. Okay, and then we on to, I don't know if anybody else that we've missed out has appeared online yet. I don't see them. I think Brad is the last presentation of the day then. Bradley, can you hear us and can you share your presentation? Yes, let me just close this, sorry. Are you doing the presentation, Brad? Yeah, okay. I'm not sure that your audio, I didn't see your audio on. Can you confirm at the back? I don't see a mic for him. Is he? I'm talking about his local. Brad, can you speak?
What's that?
Can't hear anything. That doesn't help. But he did know to come online. Can anybody else hear me online? Can you just please raise your hand or respond verbally?
Yes, we can hear you.
Thanks, Ronani. Okay, so I don't know if Brad looks like there's something wrong with Brad's muting locally or connection. He must. Any suggestions from the back? It looks like it's on his side. Brad, if you can hear us, so the suggestion is to log off and log back in. Sorry? Just type it there quickly. Okay. Or just type it to everybody. Send to everybody so they can all see. This way. Let's just make it so they can all see or communicate. Okay.
There's a mic now.
Has he got a mic? Brad, can you hear us? Okay, Brad, can you hear us? Okay, so Brad's just quickly going to log off and log back on. If we can just give him a few minutes for that. You're welcome to take a leg stretch and while we wait for him to rejoin. Brady, could you hear us? Looks like you're back online. Brad, we can't hear you.
Can you hear me now?
We can hear you now. If you can just talk up a bit.
Okay. So I've got to speak through headphones. I think it's my laptop's microphone. It's not working.
Okay, that's great. You're welcome to go ahead. I think you're audible enough.
Okay,
and if you
perfect.
can share your slideshow, or I can do it for you if you'd like.
I can share from my side.
Go for it. Thank you.
Can you see my screen? Okay, perfect.
You can see your screen. You can go into slideshow mode.
Okay. Okay.
All good on the side. The floor is yours.
Perfect. Thank you. Okay. So hi everyone. My name is Bradley van Zyl. I am a master's student in the School of Life Sciences at UKZN. I'm under the supervision of Professor Colleen Downs, Dr. Matthew Burnett, and Dr. Celine Hansen. Today I'll be talking about my project, which is monitoring the efficacy of a lowland in-stream barrier on the Tugela River and the importance of river connectivity. So the barrier under consideration is the Lower Tugela Bulk Water Supply Scheme WEA in Mandini. It is approximately 200 meters long with a 5-meter vertical height and is situated 20 kilometers upstream of the Tugela mouth. It was commissioned in June 2017 to provide water to the Mandini local municipality and surrounding areas. Its design incorporated a fishway, with the idea being that it would facilitate connectivity for migratory fish through the barrier. So the aims and objectives of my research were to examine the importance of river connectivity in the Lower Tugela, and then to monitor the efficacy of the fishway, which I'll be talking about today. So why the need for a fishway? Fishways act as a means of providing passage for migratory fish through or past the barrier. In the Lower Tugela, we have quite a few fish species that require this passage with different migratory forms, you could say. So you've got your catadromous migrators, which are your anguillid eels, like a jungle perch. And as Matthew said earlier, they require a link between the ocean and the freshwater environment, where they spawn in the ocean. The juveniles migrate up into the freshwater systems before moving back to the ocean to spawn again. You then have your amphidromous migrators, which have a dynamic relationship between the estuarine environment and the freshwater environment. They commonly have a process called larval drift that they rely on, which means that the adults will spawn in freshwater. The young will then, the larvae will then drift down with the river currents to the estuary, where they'll grow and start making their way back up to complete the process. And then you have your protamidromous migrators, which are your purely freshwater-based migration. And these are usually for spawning or feeding purposes. So we conducted 2 methods to study the efficacy of the fishway. Firstly, was the passive integrated transponder study, or PIT, as we refer to it, and that involved setting up a PIT antenna at the top of the fish ladder, which then collect fish in the catchment below it. We had to tag fish that met the minimum tagging requirements, and then we monitored the movement of these tagged fish through the fishway. And then our second method was conducting monthly sampling of the fish ladder. So for our pit tag study, our study area included 5 sites downstream of the fish ladder. The reason we chose downstream was because we were trying to see if fish will be able to migrate up through the fish ladder itself. The pit antenna setup was installed at the top of the fishway. It has an internal gap of approximately 2 meters by ½ a meter, and it is connected to a monitoring system, which is on site. So the tags we use are 12 millimeters long and 2 millimeters in diameter. They're inserted into the body cavity of the fish, and we then record the unique ID that each tag produces, along with the morphometric measurements of the fish and the release location of that fish. For a fish migrating up through the fishway, it would have to enter at the downstream entrance would have to make its way up the fish ladder before approaching the top where our pit antenna is situated, and would have to come within a 40 centimeter vicinity of this to be picked up by the monitoring system. And its unique tag ID is then recorded on the system, along with the time and date of its passage, and it's all stored on USB, which we access at a later date. For our monthly sampling, conducting sampling in 3 different sections of the fish ladder. The first was the downstream entrance, and then the lower middle turning basin and the upper middle turning basin, as we've termed it. And that involved us literally climbing into the fishway itself with an electrofishing apparatus and sampling it. So our results have shown that during our pit tag study, we caught a total of 1,225 fish downstream of the weir, of which only 107 of these met the minimum tagging requirements, and these represented 12 species of fish. From these 107 tagged fish, 8 individuals successfully navigated the fish ladder, and these comprised of 3 species, being 5 sharp-toothed catfish, 1 Mozambique tilapia, and 2 laden labia. We had planned to associate these movements of these fish with the water quality probe that we placed on site. However, this was damaged during the flood events of early 2022. Moving on to the monthly sampling, the results from that show that our fishway entrance had a high abundance of fish as well as a high diversity of species at the entrance. And we caught fish throughout all surveys, with our 2 November surveys, G&H having low abundances of fish. But as we move up into the lower middle section, the upper middle section of the fishway, you can see that the species diversity is a lot less, and as well as abundances in the lower middle section of the fishway. Unfortunately, with this sort of sampling, we don't have an idea of whether the fish moved from the upstream entrance into the fishway or from the downstream entrance. But we do have an idea when we start looking at the size class of fish that were in there. If we just look at our barb species, our Enteromias, they were the most abundant species, making up 92% of fish caught in the study. If we look at our Potamodromus migrators, that they were present, and we did catch them, but all in small size classes besides the one Clarius corypinus, and they were all predominantly caught at the entrance to the fishway. However, we do get an idea of if the fishway is working or not by looking at our Catadromus migrators. We can see we've caught 2 anguillid species as well as the one jungle perch. What we do see is that they were small size class, meaning that it just corresponds with their migratory lifestyle of moving up as juveniles from the ocean environment up into the freshwater. However, we do find that we mainly found them at the entrance, with only 1 individual being found at the upper middle section. And then the same goes with our Amphidromus migrators, which were gobioid species. Again, they were found in small size classes, predominantly at the entrance, with only 1 individual being found in the lower middle section of Glossogobius calidus. So the discussion would then be, how efficient is the fishway, or what is the efficacy of the fishway? We can see that there are high abundances of fish at the entrance of it. If we're looking at the fishway study, there's high abundances of fish at the entrance of it, but as you go up, the abundances do decrease considerably in the lower middle section. There are fish in the upper middle section, but if we also look at the pit tag study, we do see that fish did move through it. However, there were some expected migrators from the labia and labia barbus species, which we did not find moving through from the pit tag study, which is a bit worrying because that is your adult fish whose life stage at that time does require them to move upstream. So possible reasons why it may not be working as efficiently as we'd want is there's probably a poor approach efficiency. If you just look at the size of the fishway entrance, which is only about 3 meters wide compared to the large size of the barrier, it's probably difficult for the fish to locate the fishway. In addition, the traction flows coming off that we are probably not aligning to the entrance of the fishway. Additionally, there's probably poor passage efficiency with unique upstream migratory requirements of certain species not being met. But the big issue we found after all the flooding was that the fishway was highly blocked with debris, and that's an immediate barrier to any fish trying to migrate up. So just in conclusion, we can say that the fishway seems to cater for certain species, however, not all of them. And I'd just like to recommend for future fishway studies, for a pit antenna study, a minimum of 2 pit antennas would be ideal. That way you could tag fish both upstream and downstream of the weir. You could then look at the number of fish that are entering the fishway compared to the number that are actually navigating and successfully moving through it. And you can also look at things like how long it takes the fish to ascend it, as that could be an indication of how well it caters for their migratory needs. For the fishway side of things, I'd recommend sampling conducted in the way Fushia and Heath did it in 2013, which is 24 to 48 hour sampling periods. In that way, you get an idea of what fish move at different times of the day. And then you could, within that, place upstream collection nets with fine mesh, so you can catch all species that would, too small to be pit tagged. You can see which species are actually moving up, and the same could go with your downstream fish species. I'd just like to acknowledge and thank Umgeni Water and my supervisors and these other organizations for making this possible. Thank you for listening.
Thank you very much, Brad. I'd like to open the floor to any questions or comments, or anybody want to discuss anything? Looks like we're getting towards the end of the day. Wilson, please go ahead.
Thanks for the presentation, Brad. It looks like the results are, there are indications that we've got problems with the infrastructure, and it is concerning because of the negative environmental impact that one can anticipate. And I'm quite interested in any thoughts on
yes, sir.
any thoughts on any possible future design changes that can improve. So it would be useful to assist us in looking at possible solutions to fix this, because I mean the interim results are showing that we basically have a problem. So I don't know if you've got any further input on, other than expanding on that entrance to the fish ladder. Any other design changes that may improve?
Thank you, sir, for that question. So yeah, like what fish passage science is showing us is that for an efficient fishway, it needs good attraction flows to the entrance. And that doesn't necessarily mean that the entrance needs to be bigger. So just from a design perspective, if flows could be directed around that entrance area, it would bring the fish in automatically. But then in terms of fish passage through the fish ladder, it would really get down to a species level. And unfortunately, in our country, we do not have a very good understanding of our local species. We would need to look at each species, like individual migratory requirements, flow rates, what cues they need, and timings would need to be made around that, about where, like how water flows through the fishway itself.
Yeah, thanks for that, Brad. Thank you.
Thanks, Wilson. Any last final comment? Brad, if you can stop sharing.
Okay, thank you.
Okay, no final comments. I think on that point, thank you very much, Brad, for the presentation. I don't think any of the students who were supposed to be presenting online, I don't see them online, so they obviously haven't joined us. I think we just have to forego those presentations, unfortunately. So I think we're coming towards the wrap up, unless I've missed something out. Has anybody, have I missed anything out? I don't think so. Yeah, so I'd just like to, I guess, before I do a round of thanks, Wilson, would you like to make any general comments? So Dr. Wilson John is the Manager of Research and Development at Umgeni Water.
Thanks, Jeff. Jeff, thank you. Yeah, I have to start by congratulating all the researchers. Outstanding presentations. Also, Prof. Smithers for planning, leading, organizing, and directing the research group. It is, pleasing indeed to witness the energy and enthusiasm shown here at this second seminar, and more so to see how our joint efforts and plans with the UKZN, our strategic plans are unfolding. I'm quite comforted that we are progressing well towards achieving the expected outcomes. The researchers here today are the next generation of water scientists and engineers. Your contribution in the new knowledge creation is invaluable. And I see you are taking head on the difficult sector challenges and finding solutions and trying to investigate further. Harnessing, developing, and exploring cutting-edge technologies and innovation, using evidence-based approaches for water governance and policy development. Your research program is highly focused, and I'm happy and I'm grateful for that. Prof. Smithers has kept a very close eye on the relevance and what the business requirements are. Overall, it is use-inspired and perfectly aligned to our plans and strategies. And once again, well done to all the researchers. Final vote of thanks to the participants for engaging in robust discussions. Importantly, we are also honored by the presence of the leadership of Umgeni Water here today. Board Chair, Ms. Gabsi Matunjwa, the Acting Chief Executive, Dr. Sipho Manana, Executive Management, thanks for your presence and investing in your time. It shows us that this seminar and symposium is very important to the strategies and plans of the organization. It cannot be overemphasized. UKZN's academic leadership, Umgeni Water industrial leaders for their oversight and guidance. Thanks very much. The postdoctoral fellows for leading various research projects and providing the mentorship that is required to other students. And finally, the organizing committee, Susan, I must mention, Prof. Smithers, and any other support staff that I may have missed out. Thanks very much for planning this symposium. I know it takes a lot to put together something of this nature. So thanks. Back to Prof. Smithers. Thanks very much.
Thanks. Thanks very much, Wilson, for those words of encouragement. It is really pleasing to see the big impacts that or the steps forward that we're making in terms of research. I think one thing that I've taken home from today is we need to make sure that our research has impact back in society, back on industry, And so I think that's something we just need to make sure that we are well connected with industry and well connected with society to make sure we are addressing real needs. And I'm convinced we are, but we need to make sure that these are actually carried through to practice and operations, because that's really where we want to focus. I think I'd just like to reiterate some thanks. I think thank you to the students. I think they were the stars of the show. Well done to all of you. Really good to see some faces that I've probably been speaking to or communicating with for a couple of years, but haven't seen. So it's really nice to see some faces. Hopefully we'll have a better turnout next year. So I'd like to thank you all for attending. Those online, thank you also for attending. And particularly from the staff from Umgeni Water, it's really good to see you here. Thank you for spending the day with us. That's really what we're wanting to do. We really want to engage with you, and we're really wanting to encourage our supervisors and our students to engage with you, to understand the problems, to pick up new problems that we can then put our future researchers onto and future postgraduate studies onto. That's really something that we would like to do. And I think, yes, it is very significant that the acting CEO, as well as the chair of the board of Umgeni Water, are here. We really appreciate that. It was really significant. Yes, I think Susan Risco, I know you've all probably getting too many emails from her, or not too many, but quite a few reminders. I think it has been a bit of a learning curve for us in terms of invitations, so I apologize for some of those early ones in December sometime that weren't always quite clear, and wrong times of day. She's sitting in Florida at the moment, so it's a bit difficult getting the times right. But hopefully we've improved. So thanks very much, Susan, for all the work and putting everything together, and I guess hounding the students to get the presentations in, and you can see it actually worked. Some battling to present online, and we could actually help them out by having the presentations available locally. So thank you very much for that. I think the AV team, I was blown away when I came around at 4 o'clock yesterday afternoon, the amount of activity, the amount of work, the amount of preparation, setup, testing, and even through to this morning that was happening. It was really certainly an eye-opener for me. So thank you very much. I really appreciate all the support we had. I know we've had a couple of hiccups, change in venue, because the venue that was promised to us that was going to be refurbished early in January still isn't finished. So that was another story. So thank you for accommodating the change in venue, and thanks to AV to picking up and sorting out the problems where there were some changes in plans during the week, I believe. Okay. I think that's about it. And then Christine, thank you very much for joining us. Christine, your official position is, I'm not sure. She's going to be reporting on this event, making sure it gets into the media and things like that. So we really appreciate your support. Thanks, Christine, for being here. Our timekeepers, thank you very much in the front. I think some of the presenters were a little bit worried when these 2 minutes, 1 minute, 0 minutes came up, but I think it was very effective. So thanks very much for that. I think that's all. And then maybe, yeah, just to the support from the Centre for Water Resources Research, Marsha and Olatandu, they've also picked up change in venues, booking venues at the last minute is quite onerous within university systems. So, but we managed to pull it off. So that's great. So thank you all for your support. Thank you all for being here. I believe there should be tea and coffee served. The idea is for you to continue interacting over tea and coffee. I apologize for that we didn't stick very strictly to the schedule. Those of you who know me know that I don't like working like that. I expect to start on time and finish on time, but unfortunately there were things that were beyond our control, so I apologize for that. But I'm glad that you managed to stay this day and spend the bulk of your day with us, and I hope you enjoy the rest of your day and have a good weekend. Thank you. And yeah, thank you very much again to those all online. We really appreciate your input and attendance.